Today we'll create a full space shooter game from start to finish using the Flame game engine in Flutter. Alright, so after creating a new Flutter project and loading it up in our favorite IDE, there are a few things we need to do to get started. First, in order to use Flame, we need to add the Flame package to the project. So let's open up the pubspec.yaml file. Under Dependencies, let's add one for Flame. At the time of recording this video, the current version is 1.23.0. And while we're at it, we'll need two more packages for playing audio. First, for playing music, we'll use flame_audio, with the current version being 2.10.7. And for sound effects, we'll use Soundpool, version 2.4.1. Alright, and we're also going to be using some assets for the game, so let's come down to the assets section and uncomment all of this. We'll need to access two assets folders. First, for the images, we'll use assets/images, making sure to add another / to the end here. And for the audio, we'll use assets/audio/. If we save the file, we get some warnings that the assets folders don't exist. So let's fix that next. In the description for this video, you'll find a link to the GitHub repository for the finished game containing all the code and the assets. Okay, so after downloading the code, we can copy the entire assets folder into the project. And here we should see an images folder containing all the images, and an audio folder with all the music and sound effect files. If we save pubspec.yaml again, we shouldn't get any more warnings. And now we can close out of the file. Okay, now we're ready to start coding. For most games that we create with Flame, we'll start by implementing the Flame game class, which will control the game loop and make sure everything gets updated and rendered correctly on the screen. So for this, let's create a new file in the lib folder. We can call it pretty much whatever we want. To keep things simple, let's call it my_game.dart. And here, let's create a class called myGame, and the class needs to extend Flame game. Let's make sure to press Enter to import Flame's game.dart package. Okay, now when an instance of Flame game runs for the first time, its onload method will run. So we can override the method and perform all of our setup stuff in here. For example, we want the game to be full screen so that none of the device's system bars cover up parts of the game. To do this, we can type flame, import the package, access the device instance, and call its full screen method. And we want to make sure this happens before we start adding things to the game, so we can add a wait to the start of this. This means we also need to add async to the onload method declaration. Similarly, for this particular game, we want it to always be displayed in portrait mode, even if the user rotates their device. To do this, we can again type await flame.device and call setPortrait. Alright, now if we run the project, we're just going to see Flutter's default counter app. This is because we need to go into main.dart and make it actually use our game class. So first, let's get rid of everything below the main method. Now, in the main method, let's create an instance of our game by typing final myGame, import the class, then game equals myGame. Next, in the call to run app, instead of passing in const myapp, we need to pass in game widget, making sure to import the required package. Game widget requires a game argument, which we can set to our game variable. Doing all of this gives us an error in the test folder, but we won't be needing it anyway, so we can go ahead and delete the entire folder. And with that, if we run the project, we should now see a completely black screen. Not very exciting, but at least it works. Alright, now let's go back to my game. The black screen that we're seeing is the default background color of a Flame game. If we would like to change the color, we can override the background color method. And here we just need to return a color object. For example, we can do return const color.fromRGBO and pass in the RGB and opacity values for the color. So for example, 255, 0, 0, 1.0 will make the background red and completely opaque. However, we want to keep the background black for this game, so let's get rid of the background color method. We can also remove the unnecessary Dart UI imports. Now we'll work on displaying the player sprite on the screen. If we take a look in the images folder, there are quite a few images for the player. This is because the player will be able to choose from 4 different colors for their spacecraft. And for each color, we have 2 images for when the player's thruster is turned on, which we'll use in an animation, and we have 1 image for when the thruster is turned off. But for now, to keep things simple, we'll just use player blue on 0.png. Okay, so for handling the player sprite, we'll create a new file, and to keep things organized, we'll do so inside a new folder. So let's create a new folder inside the lib folder. Most of the elements that we add to a Flame game are referred to as components. So let's call the folder components. Then let's create a new file in the components folder and call it player.dart. As I mentioned a second ago, Flame games are made up of components, and Flame provides us with a variety of classes for different types of components. Most objects in our games will be position components, which can be freely moved, rotated, and scaled. However, there are also a number of classes that implement the position component class as well. It can seem a bit overwhelming at first, but when creating sprites, which are things like characters and weapons that use images, we'll mainly use either sprite component for sprites that don't animate, or sprite animation component for sprites that do animate. The player sprite for our game will eventually have an animation, so we'll need it to be a sprite animation component. But for now, we'll make it a simple sprite component, which will be a bit easier to work with. Alright, so back in player.dart, let's create a player class, extend the sprite component class, and import the components package. Like the Flame game class, component classes have an onload method that runs when the component gets added to the game, so we can override the method and use it to set up the component. The first thing we want to do in here is set the component sprite property to a new sprite object that uses the player blue on 0 image. To do this easily, the Flame game class provides a utility method called loadSprite. In order to call the method from the player class though, we need a reference to our main game object. Because this is such a common requirement, Flame provides us with a mixin for this. To use it, we can go to the end of the class declaration, add the word with, and start typing hasGame. We get 2 options here, hasGameRef and hasGameReference. These work the same way at the moment, but according to the documentation, hasGameReference is newer and is eventually going to replace hasGameRef. So let's go with hasGameReference. With this, we now have a game property that we can use to access the main game object, and we can now call its loadSprite method. And here we need to pass in a string for the file name of the image that we want to use for the sprite. This will automatically check inside the assets/images folder, so we can just put in quotations player_blue_on0.png. And to make sure the sprite finishes loading before we do anything else, let's await the call and add async to the onload method. Now at the moment, this has no effect on the actual game, And that's because we haven't actually created and added the player component to the game yet. To do this, let's go back to My Game. And here, let's first create a global variable to keep track of the player component. This needs to be a public variable as we'll access it from another class later on. We also won't be initializing it straight away, so let's do late player, import the class, then player. Next, we'll create a method that we'll call anytime we want to actually start a new game. This will happen whenever the player clicks the Start button on the title screen. So below the onload method, let's do void start game. And this method will first create the player component, and we'll keep things nice and tidy by doing this in a separate method as well. So let's create another method, and this one can be private, so let's do void underscore create player. Now let's initialize the player variable by doing player equals player. This will create the player component, but it won't actually add the component to the game. To add it to the game, we use the provided add method and pass in the player variable. Okay, now in start game, we can call underscore create player, and until we create the title screen later, we can call start game from inside the onload method. If we run the game now, we see the player sprites. By default, adding a component positions it at the top left of the screen. And if we're using an image, it will use the size of the image as the component size. To make it harder for the player to get hit by the asteroids, we'll make the sprite much smaller and start it out down near the bottom center of the screen. The coordinate system of a flame game goes from 0, 0 at the top left, and the X and Y values increase as we move down and to the right. When positioning a component, Flame uses the component's anchor point, which by default is located at the top left corner of the component's bounding box. And when first adding a component to the game, Flame positions it so that its anchor point is located right at 0, 0. However, we can change both the anchor and the position of a component at any time, including when we first create the component. For example, to immediately change the player component's anchor when initializing the player variable, we can use the cascade operator by typing ... anchor equals. Then we can access the anchor class, import the components package, and now we can choose to place the anchor at any of the corners, edges, midpoints, or center of the component's bounding box. Let's go with the center. With this, the player sprite will be centered at position 0, 0. Similarly, to set the sprite's initial position, we can add another ... then position equals. The position property is looking for a vector2 object, so we can create one by typing vector2 and passing in the X and Y values. If we wanted to, for example, position the sprite at the center of the screen, we'll need to place it at half the screen width and half the screen height. Doing this is pretty easy because we can simply use the game's size property to get the size of the screen. The size property is a vector2 object, and to get the width of the screen, we use size.x. So for the sprite's x position, we can do size.x divided by 2. Similarly for y, we can do size.y divided by 2. And now the sprite will be perfectly centered on the screen. Okay, so if we would like to place the sprite near the bottom center of the screen, instead of setting y to size.y divided by 2, we can multiply size.y by, say, 0.8, or 80% of the screen height. That should be a good starting position, but the sprite is definitely too big. To set the size, we can add another cascade operator and set the component size property. This takes a vector2 object as well, so let's try something like vector2.all100 to give it a width and height of 100 pixels. If we give it a run, it does resize the sprite, but now it looks squashed because we're not maintaining the aspect ratio of the image. So instead of setting the size here, let's go into the player class. To maintain the sprite's aspect ratio, we can resize it after the sprite has been loaded in the onload method. For example, we can do size times equals 0.3, which will set both the width and the height to about a third of the original values. Okay, with that taken care of, we'll next add a joystick to the screen so we can actually move the player sprite around. For this, Flame provides another component class called Joystick Component. With Joystick Component, we can define a knob and a background for the joystick. The background is just there for looks, and the knob is the part the player drags with their finger and which affects the movement of the player sprite. We can use any kind of position component for both the knob and the background, including sprite components with images and shape components in case we wanted to simply create a circle or something for each part. Okay, so to create the joystick, let's go to the MyGame class. Like with the player, we need to create a global variable for the joystick, and we'll make it public because the player sprite will need to access it. So let's create one by typing late joystick component joystick. Now for initializing the joystick, we'll create a new method down here. And because the player component will be accessing the joystick, we'll need to wait until the joystick has finished being added to the game before we create the player component. So for the method, let's do future void underscore create joystick. Then let's do joystick equals joystick component. For both the knob and the background, we'll create sprite components. And in the images folder, we'll set the knob using joystick knob.png and the background using joystick background.png. So when creating the joystick component here, let's set the knob property to sprite component. And in here, let's set the sprite property to await load sprite joystick underscore knob.png. Also, because the image is basically a circle, in order to maintain the aspect ratio, we just have to give the sprite a square bounding box. To do so, let's set the size property to vector2.all50, making it 50 pixels all around. Similarly, let's set the joystick's background property to a sprite component as well. For the background, we'll set sprite to await load sprite joystick underscore background.png and set size to vector2.all100. We're getting errors right now because we need to add async to the method declaration. Let's also not forget to actually add the joystick to the game by calling add and passing in the joystick variable. Alright, now in start game, let's make it an asynchronous method. And before calling create player, let's do await underscore create joystick. This will ensure that the joystick is available before the player component tries to access it. Okay, if we run the game now, we do get the joystick, but we can barely see it because it's centered at the top left of the screen. To keep it from interfering with the game, we'll move it down near the bottom left corner of the screen. To do this, we can set the joystick's anchor to the bottom left corner of its bounding box, then set its position to something like 20 pixels from the left edge of the screen and 20 from the bottom, so that it's not too close to the edges. Okay, so in the create joystick method, after setting the knob and background properties, we can set anchor to anchor.bottomleft and set position to vector2 using 20 for x and size.y minus 20 for y. Now we can see the entire joystick and we can move the knob around. Pretty cool. To make it so this actually moves the player sprite though, we need to go to the player class. Every component in a Flame game has an update method that we can override. This method runs every single frame or tick of the game loop. So if we wanted to, for example, move the player sprite up the screen during each tick, we can do something like position.y minus equals 10. Because the game loop ticks many times per second though, the sprite moves pretty fast up the screen. A flame game typically runs at a frame rate of about 60 frames per second. However, the complexity of the game as well as the speed of the player's computer can affect the frame rate. So it's never a good idea to change a component's attribute each tick by an exact amount like this, as it can have different results for each player. What we want to do instead is take into account how much time has passed between the current tick and the previous tick, and that's exactly what the dt parameter here tells us. If we multiply by dt when changing the sprite's position, it will now move at the same speed for anyone who plays the game, regardless of how fast or slow their computer is. Because dt is quite small though, the sprite moves pretty slowly. So let's try something much higher than 10, like 200. That should be a good speed. Alright, so now we need to make the player sprite only move when the player drags the joystick's knob around, and also make it move in the correct direction. To do this, we need to determine the distance and direction of the knob from the center of the joystick. And for this, joystick component provides the relative delta property. To see how it works, let's get rid of the line here for setting the position. Then let's call the print function, and let's access the joystick by doing game.joystick. It's not finding the joystick though, and that's because when we add the hasGame reference mixin, it assumes that the game object is a simple flame game instance. In order to access the joystick variable of the myGame class, we need to let the player class know that the game object is an instance of myGame. To do this, we can add some angle brackets after hasGame reference, type myGame between them, and import the class. Now we can access the joystick and print its relative delta property. If we run the game now, we can see that relative delta is a vector2 object and that it has values of 0, 0 when the knob is at the center of the joystick. As we drag it around, we get values between -1 and 1 depending on the direction and distance of the knob. X goes from -1 on the left to 1 on the right, and Y goes from -1 at the top to 1 at the bottom. Alright, so in the update method, we can take the joystick's relative delta into account when changing the player sprite's position. To do so, let's first get rid of the print statement. Then let's do position plus equals game.joystick.relative delta times 200 times dt. The player sprite will now move in whichever direction we drag the joystick knob. At the moment though, if we drag the knob only a small distance from the center, the sprite barely moves at all, because the relative delta values are very small. This might be what we want to happen in some games, but for this one, we want to move the sprite at full speed regardless of the knob's distance from the center. To do this, we can normalize the relative delta vector by calling its normalized method. This will make it so the length of the vector is always either -1, 0, or 1. Awesome. But right now, the sprite is able to go off the edges of the screen. One thing we can do is make it so when the player gets close to either the left or right edge, they instantly teleport to the opposite edge. This is called screen wrapping or wraparound, and is a common feature in space shooter games. We should also place a limit on how close the player can get to the bottom and top edges. Okay, so for all of this, let's first create a new method by typing void _handle screen bounds. We'll start by creating some variables to hold both the screen width and the screen height for easy access. So let's type final double screen width equals game.size.x. Then final double screen height equals game.size.y. Next, we'll prevent the player from going off the top or bottom edges. To do so, we can stop the sprite's Y position from becoming less than half the sprite's height, preventing it from going above the top, and from becoming greater than the screen height minus half the sprite's height, preventing it from going below the bottom. And we can do this pretty easily by setting the sprite's position.y using the clamp double function. So let's do position.y equals clamp double, making sure to import the Dart UI library. And here we need to pass in what value to clamp, which is position.y, the minimum value, which is size.y divided by 2, and the maximum value, which is screen height minus size.y divided by 2. If we now go to the update method and call _handle screen bounds after changing the position, the player will no longer be able to go off the top or bottom edges of the screen. Alright, next, back in handle screen bounds, we'll perform wraparound if the player goes over the left or right edge. First, we'll check if half of the player's sprite's width has gone past the left edge. And because the sprite's anchor is located at the center of the sprite, all we have to do to check this is type if position.x is less than 0. And if so, we can move the sprite to the right edge by doing position.x equals screen width. Similarly, for checking the right edge, we can do else if position.y is greater than screen width. Then position.x equals 0. And that should do it. Awesome. Now, one more thing to note is that if we move the player sprite over to the joystick, the sprite is currently being drawn on top of the joystick. This happens because Flame, by default, draws the components in the order in which they were added to the game. Because we're adding the joystick component before the player component gets drawn after the joystick component. However, we can actually override this behavior by changing the priority of the components. A component's priority is basically the same as an object's Z-order in other game engines, and Flame uses it to determine when the component should be drawn. The higher a component's priority, the later the component will get drawn to the screen, making it appear to be stacked on top of components with lower priorities. By default, every component gets a priority of 0, and when components have the same priority, Flame draws them in the order in which they get added to the game. To change a component's priority, we set its priority property. For example, if we want to make the joystick appear on top of the player, when creating the joystick component here, we can set its priority to something higher than 0, like 10. Now the joystick will get drawn after the player sprite. Okay, now we'll give the player sprite a break and work on spawning the asteroids. We'll start by creating a new file for the asteroid component in the components folder, calling it asteroid.dart. And here, let's create a class called asteroid and make it extend sprite components. Alright, so what we'll do with the asteroids is we'll continuously spawn them a bit above the top edge of the screen with a random X position somewhere across the width of the screen, and we'll make them move down the screen. If they reach the bottom of the screen without getting destroyed by the player, we'll remove them from the game. Also, if we take a look in the images folder, we have 3 different asteroid images. We'll randomly choose one of these images each time we create an asteroid sprite. Another thing to note is that the images are basically circular, so we can simply give each asteroid sprite a square bounding box. Okay, so back in the asteroid class, instead of first loading the sprite in the onload method, then setting the size like we did with the player sprite, we can add a constructor to the class and set the size in there. So let's create a constructor. And we can actually set the size using the Sprite components constructor by doing :super, and here setting size to vector2.all. And let's go with 120 for now. We can also go ahead and set the anchor property in here as well. Let's set it to anchor.center. Now we also want to set the position in the constructor, but we're actually going to pass in the position each time we spawn an asteroid. So we can add a named parameter to the constructor by putting some curly braces in here and typing required super.position. Next, we'll load up the sprite using a random asteroid image. We can give the constructor an empty body for now by adding a semicolon to the end of it. Then let's override the onload method. Okay, so in order to load the sprite, we'll need access to the game object. As we saw with the player component, we can do this using the hasGameReference mixin by adding with hasGameReference to the class declaration, and let's give it a type of myGame. Now we can make onload an asynchronous method, then do sprite equals await game.loadSprite. As we saw earlier, we have 3 asteroid images. To randomly choose one of the 3 images, we can take the word asteroid followed by either a 1, 2, or 3, then add .png. For generating a random number, we'll create an instance of the random class from the Dart Math library. And because we'll actually be generating random numbers quite a few times throughout the asteroid class, we'll create a global variable for the instance. So let's do final random, import the Dart Math library, then _random equals random. Now we can use this object anytime we need to generate a random number. For example, before setting the sprite and onload here, let's do final int image num, and let's set it to _random.nextInt, passing in a 3. This will randomly choose either a 0, a 1, or a 2, so to make sure we get a 1, 2, or 3, we can do +1 here. And now for the image path and load sprite, we can type asteroid $imagenum.png. Alright, now before we start spawning the asteroids, let's go ahead and make it so the sprite continuously moves down the screen. For this, we need to override the update method. We'll eventually give the asteroids random velocities, as well as make it so their size affects their velocity, but for now, we can just do position.y plus equals 150 times dt. At the moment though, even when the sprite goes off the bottom of the screen, it will still exist as part of the game, unnecessarily using up resources. So we need to make sure to remove the asteroid from the game if it goes below the bottom. To do this, let's check if the sprite has gone fully below the bottom of the screen by typing if position.y is greater than game.size.y plus size.y divided by 2. And if so, we can call the provided removeFromParent method. This will remove the component from the game, and Dart's garbage collection will then take care of releasing its resources. Okay, now we're ready to start spawning the asteroids, so let's head into mygame.dart. Just to make sure everything in the asteroid class actually works correctly, let's create a single asteroid for now and add it to the game. In the start game method, we can do all of this in one go by calling add, then asteroid, and import the class. And we need to set the position in here, so let's go with vector2 200, 0. This will position it near the top center of the screen. Okay, let's give it a run. Awesome. The asteroid starts at the top and moves down the screen. Alright, let's get rid of the line here for creating and adding the asteroid, and let's see how we can start spawning the asteroids. For easily spawning components, we can use the spawn component class. With a spawn component, we can provide a factory function for creating copies of a particular position component, we can provide a time period for how many seconds to wait between each spawn, and we can provide a shape to define the area in which the copies should be spawned. Now with the default spawn component constructor, the time period is static. So if we set it to say 1 second, it will wait exactly 1 second between each spawn. If we would like to make the spawn period more random, we can instead use spawnComponent.periodRange. With this, instead of a single period parameter, we can set a min period and max period, and it will choose a random interval between the values each time. This is what we'll use for the asteroids. Okay, so first, let's create a global variable for holding the asteroid spawner by typing late spawn component _ asteroid spawner. Then let's come down here and create a method by typing void _ create asteroid spawner. And here let's set _ asteroid spawner to spawnComponent.periodRange. For factory, all we need to do is create a function with a parameter for the index of the current component being spawned and return an instance of the component that we want to spawn, so asteroid. And here we have to provide a position, but let's just go with vector2.0 for now. For min period, let's go with 0.7 seconds, and let's go with 1.2 seconds for max period. Finally, as I mentioned before, we can set an area in which to spawn the asteroids. However, if we don't set it, it will by default make the area the size of the parent component. Since we'll be adding the asteroids directly to the game object, it will use the entire screen as the spawn area. That's definitely not what we want, but we'll leave it like it is for the moment. Alright, so after creating the asteroid spawner, we need to actually add it to the game by calling add _ asteroid spawner. Finally, we need to go to the start game method and call _ create asteroid spawner. If we run the game, it will spawn an asteroid at a random position every 0.7 to 1.2 seconds. Okay, now instead of spawning the asteroids randomly all over the screen, we want to spawn them above the screen and give them random expositions across the width of the screen. To do this, we could define a thin rectangle or something above the screen, giving it the same width as the screen and spawning the asteroids inside it. However, that would be a bit overkill. It would make more sense to simply set each asteroid's Y position to something like -100 and give it a random exposition. To do this, we'll need to use an instance of the random class, so let's create a global variable for it by typing final random, import the dartmath library, then _random equals random. Now later in the game, we'll add some pickups that also spawn at random expositions above the top edge of the screen, so we'll create a new method for generating a random spawn position. For this, let's do vector2 _ generate spawn position. And here let's return a vector2. Now for x, we don't want the components to spawn right up against the left or right edges, so let's do 10 plus _random.nextDouble times parentheses size.x minus 10 times 2. The next double method returns a value between 0.0 and 1.0, so the x position will be somewhere between 10 pixels from the left edge and 10 pixels from the right edge. And for y, we can just do -100. Alright, now back in create asteroid spawner, instead of using vector2.0 here for the asteroid's position, let's use _ generate spawn position. If we give this a try right now though, the asteroids will still spawn all over the screen. This is because spawn component by default overrides the component's position and sets it using the spawn area. To prevent this from happening and maintain the asteroid's set position, we can set the spawn component's self-positioning property to true. And now the asteroids will spawn above the top of the screen. Alright, next we'll make things less boring by giving the asteroids random speeds and angles as they move down the screen. But first, the asteroids are currently being drawn above the player sprite, which we probably don't want. This happens because the player sprite and asteroid sprites are all using the default priority of 0, and the asteroids are being drawn after the player sprite. So to fix this, let's go to the asteroid class. In the call to super, all we have to do is set priority to something less than 0, like -1. Now the player sprite will appear above the asteroids. Okay, now later in the game, we're going to give the asteroids some health. And when they run out of health after being shot a few times by the player, we'll split them into 3 smaller fragments. And we're going to make it so the smaller an asteroid is, the faster and more horizontally it can move. Therefore, when setting the velocity of an asteroid, we'll take into account its current size, and we'll need to compare it to the maximum size that an asteroid can be. For the maximum size, we'll use 120, which is the size we're currently using when creating the asteroids. And instead of directly setting the size of the asteroid to the maximum size, we'll need to pass in the size when creating the asteroid. So let's add a double size parameter, and by default we'll set it to a variable called _max_size. Then we can set the component size property here using vector2.all_size. Now let's create the max size variable. And in order to use it as the default value of the size parameter, it needs to be a constant. So let's do static const double _max size equals 120. Everything should work the same as before, but now we're able to give the asteroids different sizes. Alright, so for generating a random velocity for the asteroid, let's come down here and create a new method. It needs to return a vector2, and we can call it _generate_velocity. And here, let's return a vector2. For x, let's go with something like _random.nextDouble times 120 minus 60. With this, the asteroid's horizontal speed will be something between -60 and 60. Now for y, we want to ensure that the asteroid always moves toward the bottom of the screen. This means the vertical speed needs to be positive. So let's try 100 plus _random.nextDouble times 50. With this, y will be something between 100 and 150. Okay, now to actually put this to use, let's come up here and create a global velocity variable by typing late vector2 _velocity. And we'll set the variable inside the constructor. So let's replace the semicolon here with some curly braces. Then let's set _velocity to _generate velocity. Now in the update method, instead of doing position.y plus equals 150 times dt, let's do position plus equals _velocity times dt. And let's give it a try. Great. At the moment though, the possible velocity values will be the same regardless of the size of the asteroid. So before the return statement and generate velocity, let's type final double force factor and set it to _max size divided by size.x. With this, we're dividing max size by the current width of the asteroid, which by default is set to max size. The height is also set to max size, so if we wanted to, we could use size.y instead, as it will have the same result. And now, before returning the vector, we can multiply it by force factor. When setting the asteroid size to max size, force factor will be 1, so this won't have any effect. But if we set the size up here to something smaller than max size, like 80, the asteroids will move faster. And if we try something even smaller, like 40, they will move really fast. Alright, let's set the size back to max size. This all works pretty well, but right now, if an asteroid goes off the left or right edge, it just keeps on going until it eventually goes below the bottom of the screen and gets removed from the game. Since we're letting the player wrap around to the other side of the screen, I think it would only be fair to let the asteroids do the same. To do this, let's first cut out the code in the update method for removing the asteroid if it goes below the bottom. Then let's create a new method by typing void _ handle screen bounds. And let's paste the code in here. Now under this, we'll perform wraparound if the asteroid goes over the left or right edge. We'll do this basically the same way we did for the player sprites, checking if the asteroid has gone over the left or right edge and teleporting it to the other side if it has. With the player sprite, however, we're teleporting it once half of the sprite has gone over the edge. Because the default asteroids are pretty big though, doing it this way would cause a noticeable jump as the asteroid moves from one side to the other. So instead, we'll wait until the asteroid has gone completely over the edge before teleporting. Alright, so first, let's get the width of the screen by doing final double screen width equals game.size.x. Then let's check if the sprite has gone completely over the left edge by doing if position.x is less than negative size.x divided by 2. And if so, let's set position.x to screen width plus size.x divided by 2. Then let's do the same for the right side by typing else if position.x is greater than screen width plus size.x divided by 2, position.x equals negative size.x divided by 2. If we now call _ handle screen bounds inside the update method, the asteroids will wrap around just like the player. Awesome. Okay, moving along, let's give the asteroids a bit of a random spin as well. Doing this is pretty easy. First, let's create a global variable for it by doing late double _ spin speed. And we'll set it directly in the constructor. We don't want the asteroids to spin too much, and we'll let them spin either clockwise or counterclockwise. So let's set it to _ random.nextDouble times 1.5 minus 0.75. This will make the spin speed between negative 0.5 and 0.5. Alright, now to put this to use, let's come down to the update method, and we need to increase the component's angle property, which is the component's rotation angle in radians. So let's do angle plus equals _ spin speed times dt, and that should do it. Now the asteroids spin as they move down the screen. Next, we'll make it so the player can shoot some lasers at the asteroids. So first, let's create a new file in the components folder and call it laser.dart. Alright, so for firing the lasers, we'll place a shoot button at the bottom right corner of the screen. When the player either clicks or presses down on the button, we'll create a laser at the player sprite's current position and move it up the screen. If it either touches an asteroid or goes above the top of the screen, we'll remove it from the game. And for creating the laser sprite, we'll use the laser.png image, which is basically a long, thin, rectangular shape. Okay, so in laser.dart, let's create a laser class and make it extend sprite components. We'll also need a reference to the game object, so let's add with hasGameReference and give it a type of myGame. Then let's go ahead and add a constructor. When creating a laser, we'll pass in the player sprite's position, which we'll use as the laser sprite starting position. So let's add a named parameter to the constructor and do required super.position. We'll also want to set the anchor to the center of the sprite, so let's add a colon here and call super, then set anchor to anchor.center. We also want to make sure the laser doesn't get drawn on top of the player sprite, so let's set priority to -1. And the constructor will have an empty body, so let's add a semicolon at the end. Alright, now let's override the onload method. And here we'll go ahead and load up the sprite using the image. So first, let's make the method asynchronous. Then let's do sprite equals await game.loadSprite laser.png. The image is pretty big though, so let's reduce the size of the sprite while maintaining the aspect ratio by doing size times equals 0.25. Next, we can override the update method, and in here we can move the sprite up the screen by doing position.y minus equals 500 times dt. We also want to remove the laser from the game if it goes above the top. To do this, we can check if position.y is less than negative size.y divided by 2, and if so, we can call remove from parent. Now to actually start creating and adding lasers to the game, we first need to draw the shoot button on the screen and make it so the player can press it. For this, we'll create yet another sprite component. So let's start by creating a new file in the components folder, and let's call it shoot_button.dart. Let's go ahead and create a shoot button class, make it extend sprite component, and give it a reference to the game object. The image we'll use for the sprite is shootbutton.png. Because the image is a simple circle, we'll go ahead and set the component size directly in the constructor. So let's create a constructor for the class, call super, and set size to vector2.all80. Then add a semicolon. We'll wait to do the positioning when we create the button inside the MyGame class. We do, however, need to load up the image in here, so let's override onload, make it asynchronous, and set sprite to await game.loadSprite shoot_button.png. Okay, now before we make the button actually do stuff, let's go back to my game and add the shoot button to the game. But first, the shoot button is going to need access to the player components. This means we need to wait until the player component gets added to the game before we create the shoot button. So in the start game method, let's add a wait before the call to create player. Now in the create player method, we can change the return type to future void and make it asynchronous. Next, we'll create a global variable for the shoot button. So let's come up here and type late shoot button, import it, then underscore shoot button. Then let's come back down here and create a new method by typing void underscore create shoot button. And here let's set underscore shoot button to shoot button. With the joystick, we're setting the anchor to the bottom left and placing it 20 pixels from the left side of the screen and 20 pixels from the bottom. We'll do something similar with the shoot button, except we'll set the anchor to the bottom right and place it 20 pixels from the right side and 20 from the bottom. So after creating the shoot button here, let's add a ... and set anchor to anchor.bottom-right. Then let's do ... position equals vector2 size.x minus 20, comma size.y minus 20. We can also give it a priority of 10 like we're doing with the joystick. Finally, let's make sure to add the component to the game by doing add underscore shoot button. Then let's come back up to start game and add a call to underscore create shoot button right after creating the player. If we run the game now, we see the shoot button at the bottom right. It doesn't actually do anything right now though, so let's work on that next. To do this, whenever the player presses down on the button, we'll let the player sprite know that it needs to start shooting. And when the player releases the button, we'll tell the player sprite to stop shooting. So to start, let's go into the player class and set up some things. First, we'll need a global variable for keeping track of whether or not the player is currently shooting. So let's do bool _ is shooting, and we'll set it to false by default. Next, we'll create some public methods that the shoot button can call for setting the isShooting variable. So down here, let's first do void start shooting. And in here, let's set _isShooting to true. Then let's do void stop shooting. _isShooting equals false. Now in the update method, we'll perform the shooting logic. To do this, we'll check if the player is currently shooting, and if so, we'll fire a laser. So let's do if _isShooting. And we'll create a separate method for this as well. Let's call it _fire_laser. Then let's create the method down here by typing void _fire_laser. For now, all we'll do in here is create a laser and add it to the game. And we want to make sure to add it to the game object, not the player component, as adding it to the player component will position it relative to the player and move it around with the player, and that would be weird. So let's make sure to do game.add. Then in here, we can type laser, import the class, and pass in the position. We'll start by using the player sprite's position. However, we don't want to set the laser's position directly to the player's position, as that will make both positions point to the exact same vector2 object. Instead, we want to pass in a copy of the player's position by doing position.clone. With this, however, the laser will start out centered on the player. We should probably position it up near the front of the player a bit, which we can do by adding a vector2 to this, using 0 for x so it stays horizontally centered, and for y, something like -size.y divided by 2 should work. Okay, now to get all of this working, we need to go back to the shoot button class and make it so pressing the button calls the player's start shooting method and releasing it calls stop shooting. In order to allow a component to detect whether or not it is being pressed, there is another mix-in that we have to add called tap callbacks. With this, we can now override a few methods for receiving tap events. For example, if we override onTapDown, we can tell the component what to do when the player taps it. All we need to do in here is call game.player.startShooting. Similarly, for when the player releases the button, we can override onTapUp and call game.player.stopShooting. All right, let's give it a try. Now if we tap and release the shoot button, it will fire some lasers, then stop. If we hold down the button, it fires way too fast, and we'll fix that in a bit. But first, if we hold down the button, then move away from it before releasing, it doesn't stop shooting. This is because the component will only receive a tap up event if the player's cursor or finger is still inside the component when they release. To fix this, we also need to override the onTapCancel method and make it call game.player.stopShooting. Now it will stop shooting as soon as we move away from the button. Okay, now let's make it so it doesn't fire so many lasers at once. To do this, we can implement a cooldown period by only creating a new laser if a certain amount of time has elapsed since the previous laser was created. And we're actually done with the shoot button class now, so we can close out of the file. Then let's go back to the player class. To start, we'll need a couple new global variables. The first one will be for the cooldown period, or how much time to wait between each laser. This value won't change, so we can do final double _fire cooldown and set it to 0.2 for 0.2 seconds. We'll also need a variable for how much time has elapsed since the previous shot. So let's do double underscore elapsed fire time and initialize it to 0.0. All right, now let's head into the update method. And here, before checking if the player is shooting, let's do underscore elapsed fire time plus equals DT. Now, apart from checking if is shooting is true, we need to add to the condition here by typing and underscore elapsed fire time is greater than or equal to underscore fire cooldown. With this, a new laser will only be created if the player is shooting and at least 0.2 seconds have elapsed since the previous laser was created. However, we also need to make sure to reset the time in here after firing a laser by doing underscore elapsed fire time equals 0.0. Now let's give it a try. Awesome. One problem we have though is that if you're using an emulator like I am for testing the game, we have no way of moving and shooting at the same time. So what we can do is, we can make it so pressing the arrow keys on the keyboard will also move the player sprites. To do this, we first need to add another mixin to the player class called Keyboard Handler. With this, we can now override the onKey event method and tell it what to do when certain keys are pressed. But first, we need to create a global variable for keeping track of the keyboard movements. So let's create one by typing final vector2 underscore keyboard movements, and we'll initialize it to vector2.0. Also, for some reason, overriding onKey event might import the wrong packages here. Instead of these, we want to import package flutter/services.dart. All right, now let's come back down to onKey events. And here we get a set containing all the keys that are currently being pressed. So what we can do is we can first set underscore keyboard movement.x to 0, then change it based on whether the left arrow key or the right arrow key is being pressed. So first, for the left arrow, let's do underscore keyboard movement.x plus equals, and we'll use a ternary statement. So let's do keyPressed.contains logical keyboard key.arrow left (-1:0). So if the left arrow key is being pressed, keyboard movement.x will become -1. Otherwise, it will stay at 0. Similarly, for the right arrow, we can duplicate this line, change arrow left to arrow right, and change -1 to 1. Then for the vertical movement, we can duplicate all of these lines, change all the X's to Y's, change arrow left to arrow up, and change arrow right to arrow down. Finally, instead of returning super.onKey event here, we want to return true. This will let the super class know that we handled the key events ourselves, so it doesn't need to do anything. Okay, now we need to actually take the keyboard movement values into account when updating the player sprite's position. For this, let's come up to the update method. And here, before changing the position, we can combine the joystick input with the keyboard movements. To do so, let's type final vector2 movement equals game.joystick.relative delta plus underscore keyboard movements. Then in here, we can do movement.normalized. Okay, now at the moment, this won't actually work. And that's because there is one more thing we need to do, which is to tell the MyGame class that it contains components that handle keyboard events. To do this, all we have to do is add a mixin to the class called hasKeyboardHandlerComponents. And now we can move by pressing the arrow keys. The joystick still works as well. Perfect. Okay, next, we'll make it so when a laser hits an asteroid, both the laser and the asteroid get removed from the game. In order to detect collisions between components, we have to tell the game which areas of the components are hittable. For this, we add one or more hitboxes to the components. Let's start with the laser component. we'll add a hitbox inside the onload method. And it doesn't really matter if we do this before or after setting the sprite and the size, as Flame will by default automatically resize the hitbox's bounding box to match the size of the parent's bounding box. So somewhere in here we can call the component's add method, and we have 3 hitbox types to choose from: circle hitbox, rectangle hitbox, and polygon hitbox, which allows us to define a more complicated shape for the hitbox. Since the laser sprite is basically a rectangular shape, we can go with rectangle hitbox, and we'll need to import the collisions package. And here we can set the size of the rectangle, but like I said, it will by default use the same size as the parent component, which is what we want. The hitbox will also be positioned relative to its parent's position, so as a laser moves up the screen, its hitbox will move along with it. Alright, next, in order to tell the component what should happen when its hitbox collides with the hitbox of another component, we need to add the collision callbacks mixin to the class. We can now override the onCollision method. With this, we get a set of intersection points as well as the component that we're colliding with. So what we can do is we can check if other is asteroid and import the class. And if it is an asteroid, we can call remove from parent, which will remove the laser from the game. And we can remove the asteroid from the game as well by calling other.remove from parent. But before this will work, we need to go to the asteroid class and also add a hitbox to it. And we can do so from inside the constructor as well. Because an asteroid is basically a circle, we can use a circle hitbox. Okay, and before we give this a try, there's one more thing we need to do. Just like with handling keyboard events, we need to tell the game that some of its components use collision detection. To do this, we go to the MyGame class and add the has collision detection mixin. And now, whenever a laser touches an asteroid, both the laser and the asteroid disappear. Alright, next we'll give the asteroid some health so that the player has to shoot them multiple times in order to destroy them. To do this, let's go to the asteroid class and we'll create a global variable for the health. And we're actually going to make it so the smaller the asteroid size, the less health it starts out with. So first, let's define the maximum health an asteroid can have by doing final double underscore max health equals 3. We'll use this for the largest asteroids. Now let's create a variable for the asteroid's current health. We'll set the variable inside the constructor, so let's do late double underscore health. Okay, so in the constructor, let's type underscore health equals size divided by underscore max size times underscore max health. With this, an asteroid using the maximum size will get the maximum health, and smaller asteroids will get less health. Alright, so now we need to create a method for dealing damage to an asteroid. We'll be calling the method from inside the laser class's onCollision method, so it needs to be a public method. Okay, so down here, let's do void take damage. First, we'll reduce the asteroid's health by doing underscore health minus minus. Next, we'll check if the asteroid has run out of health, and if so, we'll remove it from the game. So let's do if underscore health is less than or equal to 0, remove from parent. Finally, we need to go back to the onCollision method of the laser class, and instead of calling other.remove from parent here, we can call other.takedamage. And now it should take 3 shots to destroy an asteroid. Excellent. At the moment though, it's not very obvious that an asteroid is taking damage whenever we shoot it. So one thing we can do is apply a flashing effect to an asteroid whenever it gets hit. For creating effects in a Flame game, we can choose from one of the many effect classes. These basically allow us to change the attributes of a component in certain ways over a specified amount of time. For example, with Move By effects, we can move a component by, say, 100 pixels in 1 second, With opacity effect, we can gradually reduce a component's opacity, and with size effect, we can make a component continuously grow and shrink. To make an asteroid flash, we can make its color quickly change to white, then back to its original color. And for this, we can use the color effect. Okay, so in the asteroid class, let's first create a method down here for creating the flash effect by typing void _ flash white. Then let's create a variable for the effect by typing final color effect, and we'll need to import the effects package, then type flash effect = color effect. One thing we need to provide here is what color the component should become. We want it to turn white, so we can do const color, import the Dart UI library, then .from RGBO, and use 255, 255, 255, 1.0. Every effect in Flame also requires a controller to tell the effect how it should behave. For this, we can create an instance of the effect controller class. And here we can provide a duration for the effect in seconds. We want the flash to happen pretty quickly, so let's go with something pretty small like 0.1. Also, by default, an effect will only run in a single direction. So at the moment, the asteroid will become white over 0.1 second, then stay white. To make it go back to its original colors, we have to set alternate to true. There's also an infinite option, which is set to false by default, meaning the effect will only happen once. If we set it to true, the effect will repeat forever. But of course, we only want the asteroid to flash once each time we shoot it, so we'll leave it turned off. Okay, and another property we can set is curve. This controls the smoothness of the animation, and the options are provided as constants in the curves class from the Flutter widgets package. The default is linear, which basically means no smoothness. Because the effect happens so quickly, it doesn't really matter what we choose, but I generally like to go with ease in out, which starts out slow, then speeds up, then slows down again near the end. Okay, and that should be it for creating the effect. So now we need to actually add it to the asteroid, which we can do by simply calling add and passing in the flash effect variable. Also, we're currently getting a warning because after importing the Flutter widgets package, we no longer need to import the Dart UI library. Alright, finally, let's come down to the take damage method, and in the if statement for checking if health is less than or equal to 0, we can do else, then call _flash white. And now the asteroids will flash white whenever we shoot them. Nice. To make it even better, we can apply some knockback to the asteroids, pushing them back up the screen a bit whenever they get shot. For this, we'll use the move by effect. So to start, let's come down here and create a new method by typing void _apply knockback. And here, let's create a variable for the effect by doing final move by effect, knock by effect = move by effect. For this, we have to provide an offset, which is a vector2 that tells it how far it should move the component by the end of the effect's duration. So let's do vector2, and we don't want it to move horizontally, so let's go with 0 for x, and for y, let's try -20 to move it up by 20 pixels. We also have to provide a controller, so let's do effect controller, and all we need to do in here is set duration to something pretty small, like 0.1 seconds. Alright, and let's go ahead and add the effect to the asteroid by doing add knockback effects. At the moment though, the asteroid's velocity will interfere with the knockback effect. So to fix this, before applying the knockback effect, we want to basically turn off the asteroid's velocity. Then, once the effect has finished, we want to restore the original velocity. In order to do this, we'll first need to create a global variable for storing the original velocity. So let's do final vector2 _ original velocity, and we can initialize it to vector2.0. Then in the constructor, after setting the velocity variable, we can give original velocity the same values by doing _original velocity.setFrom _velocity. Okay, now back in the apply knockback method, before creating the effect, let's zero out the asteroid's velocity by doing _velocity.setZero. Next, we need to create a method for restoring the velocity. So let's create one down here by typing void _restore velocity. And here, all we need to do is call _velocity.setFrom _original velocity. Finally, we need to call the restore velocity method after the effect has finished. To do this, the effect classes have an onComplete property for providing a callback function to call whenever the effect is finished. So let's set it to _restore velocity. A problem we have now, though, is that if an asteroid gets hit multiple times very quickly, it might add more than one knockback effect to the asteroid at nearly the same time. Then, when the first one finishes, it will restore the velocity, causing problems to occur with the other effects. To prevent this from happening, we can keep track of whether or not the asteroid is currently being knocked back, and if it is, we won't add another knockback effect to it. Okay, so first, let's create another global variable by typing bool _is_knockback and set it to false. Now at the top of apply knockback, let's type if _is_knockback return. Then below this, let's do _is_knockback equals true. And finally, in restore velocity, we can do _is_knockback equals false. Alright, all we need to do now is come up to the take damage method, and in the else part here, besides calling flash white, we can also call _apply knockback. Now let's give it a try. Looking good. Okay, and one final way we can improve the destruction of the asteroids is to create some explosions with flashes of light and particle effects. To start, let's create a new file in the components folder and call it explosion.dart. And here let's create a class called explosion, and this time we'll extend the plain old position component class. And let's give it a reference to the game object. Alright, so what we'll do is, when an asteroid runs out of health, we'll create a flash of light, which will be a simple white circle that quickly fades out. And at the same time, we'll create some dust particles, which will be small circles of various shades of brown that quickly spread out before disappearing. Thinking ahead though, we're also going to add some explosions when the player gets destroyed, and for this we'll use smoke and fire particles. Therefore, when creating an explosion, we'll need to pass in the explosion type. So first, above the explosion class declaration, let's create an enum for the types by typing enum explosion type, curly braces, dust, smoke, fire. Then inside the class declaration, let's create a variable for the type by doing final explosion type. We're also going to allow different sizes for the explosions, so let's create a variable for this as well by doing final double explosion size. And since we're going to be using a lot of randomization, let's go ahead and create a random instance by doing final random import Dart math, then _random equals random. Okay, now let's create a constructor for the class. This will need some parameters, so let's put some curly braces in here, then do required super.position, required this.explosion size, required this.type. Then add a semicolon at the end. Next we'll create a couple methods, one for creating the flash and one for creating the particles, and we'll call them from inside the onload method. So first, for creating the flash, let's do void _create flash. As I mentioned before, this is going to be a white circle that quickly fades out. To create circles in Flame, we can use the Circle Component class. So let's do final circle component flash equals circle components. With circle components, we can provide a radius for the circle. So let's set it to explosion size times 0.6. To set the color, we use the paint property. For this, we have to provide an instance of the paint class from the Flutter widgets package. And we can set its color by doing ... color equals. And let's set it to pure white by typing const color.fromRGBO 255, 255, 255, 1.0. Finally, let's set the component's anchor to anchor.center to center the flash on the explosion. Alright, now to make the flash fade out, we can add an opacity effect. With the opacity effect class, we have a few options. We can change a component's opacity by a certain amount, fade the component in, fade it out, or change its opacity to a certain amount. We want to fade the flash out, so we'll use the fade out constructor. Okay, so let's create the effect by doing final opacity effect, import the effects package, then fade out effect equals opacity effect.fade out. All we need to do in here is create an effects controller and set the duration to something like 0.3. Then we can add the effect to the flash by doing flash.add opacity effect. And finally, we can add the flash component to the explosion component by doing add flash. Okay, now we need to override the onload method, and in here we'll call _createFlash. At the moment though, even after the flash fades out and we can no longer see it, both the flash component and the explosion component will still exist inside the game using up resources. So we need to make sure the explosion component eventually gets removed, which will also remove its child components, including the flash. To do this, we can add a remove effect to the explosion component. Adding a remove effect to a component will, after a specified delay, remove the component from its parent. One thing to know about effects in Flame, though, is that they run simultaneously. Therefore, when setting the remove effect's delay, we need to make sure to give the fade out effect enough time to finish. And we're also going to be adding the particles to the explosion component, and we'll need to wait for them to finish as well. So to be safe, we'll use a delay of 1 second. Alright, so let's create and add a remove effect to the explosion component by doing add remove effect and set delay to 1.0. Okay, to make sure everything works correctly so far, we need to go to the Asteroid class and tell it when to create an explosion. This should happen in Take Damage when the asteroid has run out of health. We'll create an explosion inside a new method, which we'll call _createExplosion. Now let's create the method by doing void _createExplosion. And here, let's create an explosion by typing final explosion, import the class, then explosion equals explosion. For the position, we'll use a copy of the asteroid's current position, so let's set it to position.clone. For explosion size, let's do size.x, and for explosion type, let's do explosion type.dust. Finally, we need to add the explosion to the game. To do this, we don't want to just call add explosion, as this will add the explosion as a child of the asteroid. And as soon as the asteroid gets removed from the game, the explosion will also get removed. Instead, we want to add it directly to the game object by doing game.addExplosion. And with that, if we now run the game, we get a flash of light whenever an asteroid gets destroyed. Awesome. Okay, now we can go back to the explosion class and create some particles. First, we'll create a method for generating some colors based on the explosion type. For this, let's do list, give it a type of color, then _generate colors. And here we can use a switch statement to check the explosion type, and for each type we'll return a list of colors. In order to not bore you too much, I'll skip through this part. Alright, so we're returning 3 brown colors for dust, 3 gray colors for smoke, and 3 yellowish orange colors for fire. With that taken care of, let's create another method by doing void_createParticles. Let's start by creating a variable for the list of colors by typing final list color colors equals _generate colors. For creating particles in Flame, we have the particle system component class. To use it, we pass in an object of type particle, and for this we have several classes to choose from, including moving particle, rotating particle, scaling particle, and sprite animation particle. Because we want the explosion particles to move, we'll go with moving particle. Okay, so let's create a particle system by doing final particle system component particles equals particle system components. And let's set the particle property. Now we don't just want to pass in an instance of moving particle, as that will only create a single particle. Instead, we want to do particle, import the particles package, then .generate. With this, we can set the count property to tell it how many particles to generate. Let's randomize it a bit by doing 8 plus _random.nextInt 5, which will create between 8 and 13 particles. And for actually generating the particles, we set the generator property. For this, we can create a function with a parameter for the index of the current particle. And the function needs to return the type of particle that we want to create, so moving particle. With moving particle, we have to provide a child of another particle type, basically to define the appearance of the particles. We want to create circles for the particles, and for this we can use the circle particle class. For a circle particle, we set the paint property to a paint object that defines the color. For the color, we'll randomly choose from the colors list. So on the paint object, let's do .color equals colors _random.nextInt colors.length. And just for fun, let's also randomize the opacity a bit by doing .width values and setting alpha to 0.4 plus _random.nextDouble times 0.4 to make it between 40% and 80% opaque. Okay, and another property we can set for the circle particle is radius. We want the sizes of the circles to be pretty small and slightly random. So let's go with explosion size times parentheses 0.1 plus _random.nextDouble times 0.05. Alright, and for the moving particle, we also have to set the to property, providing it with a vector 2 for the final offset of the particle. And we'll randomize this as well, allowing bigger particles to move further than smaller particles. So for x, let's do open parentheses _random.nextDouble minus 0.5 close parentheses times explosion size times 2. And we can actually use the same math for y. Okay, and we don't want the particles to last forever, so we can also set the moving particle's lifespan property, telling it how many seconds the particle should live. Let's also randomize this by typing 0.5 plus _random.nextDouble times 0.5, so between 0.5 and 1 second. Finally, below all of this, let's add the particle system to the explosion component by doing add particles. All we need to do now is come up to the onload method and also call _createParticles. And with that, we now get some dust particles whenever we destroy an asteroid. Very cool. Alright, now let's go back to the asteroid class and make it so the asteroids can split up into smaller fragments. For this, when an asteroid runs out of health, we'll continue removing it from the game, but we'll also create 3 new asteroids at the same location, and we'll reduce their size by 1/3 of the maximum asteroid size. And we'll only do this twice. So the maximum size asteroids will split into 3 asteroids that are 2/3 the max size. Then when those asteroids run out of health, we'll split them up into 3 new asteroids at 1/3 the max size. That should be small enough, so when these asteroids run out of health, we'll just remove them from the game and not split them up. Also, because we're setting an asteroid's starting health to size divided by max size times max health, the medium-sized asteroids will start with a health of 2, and the smallest ones will start with a health of 1. Okay, so to start, let's come down here and create a method for splitting an asteroid by doing void_split asteroid. We only want to split an asteroid if its size is greater than 1/3 the max size. So let's first do if size.x is less than or equal to _max size divided by 3, return. Otherwise, we'll create 3 new asteroids using a for loop. So let's do for int I equals 0, I less than 3, I plus. And here, let's create a new asteroid fragment by typing final asteroid fragment equals asteroid. For the position, we want the fragment to start out at the current asteroid's position, so let's set it to position.clone. And we also want to set the fragment size. For this, we'll take the current asteroid size, so size.x, and subtract it by 1/3 of the max size, so _max size divided by 3. Then below all of this, we want to add the fragment to the game object, not the asteroid, so let's do game.add_fragment. Now we just need to come up to the take damage method, and when health is less than or equal to 0, we can also call _split asteroid. Alright, let's give it a try. If we shoot a big asteroid 3 times, it splits into 3 smaller asteroids, which when shot 2 times, splits into even smaller asteroids. And the smallest ones have a health of 1 and don't split up. Also, notice that the smaller asteroids have smaller explosions. Perfect. Okay, things are coming along pretty well now, but at the moment, shooting asteroids, besides being fun, is kind of pointless. So next, we'll let the player rack up some points as they shoot the asteroids. For this, we'll display a score near the top center of the screen and increase it each time the player shoots an asteroid. Okay, so to start, we'll need a global variable for keeping track of the score, and we'll create it inside the MyGame class. So in here, let's do int _score and initialize it to 0. And we'll also need a global variable for holding the score display so that we can update it throughout the game. The score display will of course use text, and for creating text in a Flame game, we have the text component class. So to create a variable for the display, let's type late text component _score display. Alright, now for creating the score display, we'll use a new method. So let's come down here and type void _create score display. We'll create the score display whenever the player clicks the start button on the title screen. The first time this happens, the score will be initialized to 0, but anytime afterwards it won't be. So let's first make sure to reset the score by doing _score equals 0. Now let's create the text component by doing _score display equals text components. For setting the text of a text component, we use the text property. This takes a string, so we can put a 0 inside some quotes. Next, for positioning the display, we'll center it vertically on the screen and place it 20 pixels from the top. So first, we can set the component's anchor to anchor.topCenter, then set its position to vector2 size.x divided by 2, 20. We can also go ahead and set priority to 10, making sure it gets drawn on top of the player and asteroid sprites. Okay, and to define the appearance of the text, we use the text renderer property. This takes a text paint instance, and we can set the text paint style property to const text style. This is showing to import the Dart UI library, but that's not actually going to work. Instead, we need to come up here and import the Flutter material.dart package. Okay, and text style, of course, has a color property for setting the color of the text. Let's go with colors.white. Then let's set font size to 48, font weight to fontweight.bold, and to make sure the score stands out well, let's set the shadows property. This takes a list of shadow instances, so let's add some brackets and create one. Let's set the color to colors.black, set the offset to offset 2,2, and set blur radius to 2. Next, below all of this, we need to add the score display to the game by doing add_score display. And finally, let's come up to the start game method and let's call _create score display. And with that, we'll see a white 0 at the top center of the screen. Alright, now let's make it so shooting the asteroids actually updates the score. For this, we'll create a public method in the MyGame class, which we'll call from the Asteroid class whenever an asteroid gets hit. So let's create the method by typing void increment score. And for a parameter, let's do int amount for how much to increment the score by. Then inside the method, let's do _score plus equals amount. And to update the score display text, we can do _score display.text equals _score.toString. Okay, now let's go to the asteroid class, and in the take damage method, if the asteroid still has health, we'll increment the score by 1, and if it has run out of health, we'll increment it by 2. So in the if part, let's do game.increment score 2. Then in the else part, let's do game.increment score 1. And that should be it. Now the score will update as we shoot the asteroids. At the moment though, the score display looks a bit boring. To make it better, we can add a pop effect, where the display grows a bit, then shrinks back down each time it increases. For this, we'll add a scale effect to the score display whenever we increment the score. Each component has a scale property, which is a vector 2 set to 1.0, 1.0 by default. Increasing it will make the component grow, and decreasing it will make it shrink. With scale effect, we have two constructors, scaleEffect.by for scaling a component by a certain amount, and scaleEffect.to for scaling it to a certain amount. Okay, so let's go back to the increment score method in MyGame. And here, let's create the pop effect by typing final scale effect, import the effects package, then pop effect equals scale effect, and let's go with the to constructor. First, we need to set a target scale, which takes a vector 2. One thing to know about this, though, is that each time we call increment score, a new scale effect will be added to the component. And if there are still 1 or 2 other scale effects running on the component, the effects will actually be compounded, and the component will become even bigger. Therefore, we should only increase the scale by a small amount each time. And we want to increase it by the same amount in all directions, so let's go with something like vector2.all 1.2. Alright, and we also need to set a controller, so let's do effects controller. Similar to the target scale, we should keep the duration pretty short. So let's go with 0.05. We also want the display to shrink back to its normal size, so let's set alternate to true. And to make the effect look smoother, we can set curve to curves.easeInOut. Finally, let's add the effect to the display by typing _score display.add pop effect. We now get a cool pop effect each time we score a point. And notice that the score display gets even bigger if we score multiple points very quickly. Alright, now that the player can rack up points by destroying asteroids, it's time to let the asteroids have some fun by destroying the player. But first, as we discussed earlier, if we take a look at the images, the player sprite actually has a 2-frame on animation with a subtle change of the thruster fire. So let's get the animation working. To do so, we need to go to the player class, and instead of extending sprite components, we need to extend sprite animation components. Then let's come down here and create a method for loading the player animation. For this, let's type future with a type of sprite animation, then underscore load animation, and make it asynchronous. And in here, let's return sprite animation.spriteList. This requires a list of sprites, one for each frame in the animation. So let's add some brackets, and for the first sprite, let's do await game.loadSprite and give it the first blue on image, so player_blue.onZero.png. Then we can duplicate this line and change it to player_blue_on1.png. Okay, and besides the list of sprites, we also have to set the step time property, which is how many seconds each frame should appear. We want the animation to be pretty fast, so let's go with 0.1. Finally, we want to set the loop property to true so that the animation runs continuously. Alright, now let's go up to the onload method, and instead of setting the sprite property here, we can set the animation property to await_load animation. And now the player sprite will animate. Awesome. Okay, now we'll work on the player destruction. For this, whenever the player sprite touches an asteroid, we'll turn the player sprite white, fade it out, and create a series of explosions at random points on the sprite. So to start, let's create a new method for handling the player's destruction. For this, we can do void_handle_destruction. First, instead of letting the player sprite's animation continue running, we'll make the sprite use the off image, showing that the spaceship is no longer turned on. Doing this isn't as simple as setting the component sprite property though, because sprite animation components don't have a sprite property. Instead, we have to set the animation property to a single frame animation. So let's set it with sprite animation.spriteList. And here, even though we're only going to use a single sprite, we still have to pass in a list. So let's add some brackets. Then let's do await game.loadSprite and pass in player_blue_off.png. And for step time, to make the animation static, we use double.infinity. We also need to make the method asynchronous. Next, to make the sprite turn white, we can add a color effect to the components. So let's do add color effect and import the effects package. With this, we have to provide the color to change to, so let's make it white by doing const color.fromRGB0 255, 255, 255, 1.0. Then let's set the controller with effect controller, and to make the effect happen instantly, we can set duration to 0.0. Alright, now we'll add an opacity effect to fade the sprite out. So let's do add opacity effects. And for the controller, let's do effect controller and set duration to 3.0 for 3 seconds. Now before we start creating the explosions, let's go ahead and make sure all of this is working correctly. To do this, we first need to add a hitbox to the component so that it can collide with things. So let's come up to the onload method and let's type add rectangle hitbox, importing the collisions package. Next, we need to detect whether or not the player's hitbox has collided with an asteroid's hitbox. To do this, we first need to add the collision callbacks mixin to the class. And now we can come down here and override the onCollision method. And here, let's check if other is asteroid, importing the asteroid class. And if it is, we can call _handle destruction. At the moment though, handle destruction will keep on getting called whenever an asteroid touches the player's sprite, even when the sprite is already being destroyed. So we only want to check for collisions if the player isn't currently being destroyed. To do this, we first need to come up here and create a global variable for keeping track of whether or not the player is being destroyed. For this, let's type bool underscore is destroyed and set it to false by default. Now let's come down to the handle destruction method, and somewhere in here, let's set underscore is destroyed to true. Finally, let's come back to on collision, and before checking if other is an asteroid, let's type if underscore is destroyed, return. And with that, if we now run the game and touch an asteroid, the player sprite switches to the off image, turns white, and fades out. Excellent. However, we're actually still able to move around and shoot as we're being destroyed. To fix this, we just need to go to the update method, and before changing the sprite's position, let's do if underscore is destroyed, return. Now we can no longer move or shoot as we're being destroyed. Alright, now let's work on the explosions. We'll use some randomizations for this, so let's first come up here and create a global random variable by doing final random, import the Dart math library, then underscore random equals random. Now let's come down here and create yet another method by typing void underscore create random explosion. For the position of each explosion, we'll use a random point on the player sprites. So to generate a position, let's do final vector2 explosion position equals vector2. For x, let's do position.x minus size.x divided by 2 plus underscore random.nextDouble times size.x. This will choose an x that's somewhere between the left and right sides of the player sprite's bounding box. Similarly for y, we can do position.y minus size.y divided by 2 plus underscore random.nextDouble times size.y. Alright, and we'll also randomly choose between the smoke and fire particle types. So for this, let's do final explosion type, import the explosion class, then explosion type equals underscore random.nextBool question mark explosion type dot smoke colon explosion type dot fire. Now let's create the explosion by typing final explosion explosion equals explosion. For the position, let's use explosion position. For the size, let's do size.x times 0.7. And for the type, let's use explosion type. Finally, let's add the explosion to the game by doing game.addExplosion. Alright, now when creating the explosions, we don't want to just create a whole bunch of them all at once. Instead, we want to have a short delay between each one. To do this, we can use an instance of Flame's timer class. With the timer class, we set a limit for how many seconds to wait between each tick of the timer. We can provide a callback function that the timer should call each time it ticks. We can tell it whether or not it should repeat the ticking. And we can tell the timer whether or not it should start ticking as soon as we create it. Okay, so back at the top of the player class, let's create a timer variable by typing late timer underscore explosion timer. And we'll go ahead and initialize it in the constructor. So first, let's create a constructor. And in here, let's type underscore explosion timer equals timer. For the duration, let's go with 0.1. Then let's set the onTick property to underscore create random explosion. We also want the timer to repeat, so let's set repeat to true. And we don't want the timer to start until we tell it to, so let's set auto start to false. Okay, now for starting the timer, let's come down to the handle destruction method, and somewhere in here, let's call underscore explosion timer dot start. This won't work just yet though, because we also need to update the timer every frame. To do this, let's come to the update method. We only want to update the explosion timer if the player is being destroyed. So in the if underscore is destroyed block here, let's call underscore explosion timer dot update and pass in DT. Okay, and if we now touch an asteroid, we get some random explosions on the sprites. However, the explosions keep getting created even after the player sprite has completely faded out. To fix this, let's come back to the handle destruction method. When the player sprite has finished fading out, we want to stop the explosion timer, and we can do this by setting the onComplete property of the opacity effect here, creating an anonymous function, and calling _explosion_timer.stop. And actually, one more thing we want to do after the component has finished fading out is remove it from the game. So let's add a remove effect to the components. For the delay, remember that all the effects run simultaneously, so we need to wait at least 3 seconds before removing the component, giving the opacity effect enough time to finish. However, we also want to give it enough time to stop the explosion timer, so just to be safe, let's set the remove effects delay to 4.0. And now the explosions will stop after the player sprite has finished fading out. That looks pretty cool, but to make it look even better, we can have the player sprite slowly move down the screen as it explodes. For this, we can use the move effect. The two most useful move effect constructors are moveEffect.by for moving a component by a certain offset, and moveEffect.to for moving a component to a certain destination. What we'll do is we'll move the player down the screen by about 200 pixels or so the entire time that it's fading out. So we'll use moveEffect.by. Alright, so let's add a move effect to the player component by typing add moveEffect.by. For the offset vector, we only want to move the component downward, so let's do vector2 0, 200. Then let's create a controller by typing effect controller, and we want it to happen the entire time the component is fading out, so let's set duration to 3.0. Now let's give it a try. Very cool. Okay, so eventually, when the player dies, we'll bring up a game over screen with buttons that the player can press to either restart the game or go back to the title screen. But first, it's currently pretty easy for an asteroid to hit the player. It actually doesn't even have to touch the player's sprite. It just has to come within the sprite's bounding box. The reason for this is that we're using a rectangle hitbox for the player's hitbox, which by default expands to take up the component's entire bounding box. So to fix this, one thing we could do is use a polygon hitbox, providing it with a lot of different points to create the shape that we want. However, a simpler method would be to continue using a rectangle hitbox, but reduce the width and height a bit. Doing it this way will make it so most of the player sprite's wings won't be included in the hitbox. That might be a problem in some games, but I think it's actually a good idea for this one. Alright, so to set the rectangle hitbox's size easily, we can use the relative constructor. This allows us to set the hitbox's size relative to the parent size. So when adding a rectangle hitbox to the player component here, let's do rectangle hitbox.relative. And here we need to pass in a vector2 to define the hitbox's size in relation to the parent size. For example, if we would like to make the width 60% of the parent's width and the height 90% of the parent's height, we can do vector2 0.6, 0.9. We also need to set the parent size property, so let's set it to size to use the size of the player components. And in order for this to work properly, we need to make sure that we're adding the hitbox after changing the player component size here. Okay, and finally, we want to center the hitbox inside the player component by setting its anchor to anchor.center. Alright, and for testing purposes, let's go to the MyGame class, and in the onLoad method, let's set the debug mode property to true. This will show the bounding boxes of all the components and hitboxes. So if we run the game now, we can see a bounding box around the player sprite, as well as a smaller box inside the sprite for its hitbox. We can see this with the asteroids as well. And now an asteroid has to get closer to the player sprite in order to trigger a collision and destroy the player. That definitely makes things a bit easier for the player, but the game is still pretty difficult. So to increase the player's chance of survival, we'll spawn some pickups that will enhance the player's abilities. First, we don't need to see the bounding boxes anymore, so let's remove the debug mode equals true line. Then let's create a new file in the components folder called pickup.dart. Okay, so if we take a look in the images folder, we can see that we have 3 different types of pickups. A bomb pickup, which will set off a flash of light that spreads out and destroys any asteroids that it touches. A laser pickup, which will temporarily allow the player to shoot in 3 different directions at once. And a shield pickup, which will temporarily make the player invincible and allow them to destroy asteroids just by touching them. Alright, so to start, let's create an enum for the pickup types by typing enum pickup type, curly braces bomb, laser, shield. Then let's create the pickup class by typing class pickup extend sprite component with has game reference my game. We'll only need 1 global variable for the type, so let's do final pickup type. Now let's create a constructor for the class. We'll add a couple named parameters in here, one for the position and one for the type. So let's do required super.position, required this.pickup type. Also, because the pickup images are basically circles, we'll go ahead and set the size by calling the super constructor, and let's set the size to vector2.all100. Let's also go ahead and set the anchor to anchor.center. And the constructor will have an empty body, so let's add a semicolon here. Next, let's override the onload method and make it asynchronous. And here we'll use the pickup type to load up a sprite using the corresponding image. To do this, we can set the sprite property to await game.loadSprite, $ open curly brace pickup type.name close curly brace underscore pickup.png. And because we'll need to handle collisions between the pickup components and the player component, let's go ahead and add a hitbox to the component by typing add, and I think a circle hitbox would make the most sense here. Okay, now let's override the update method. And here, like with the asteroids, we'll move the pickup down the screen. So let's do position.y plus equals 300 times dt. And we also need to remove the pickup from the game if it goes below the bottom. So let's do if position.y is greater than game.size.y plus size.y divided by 2, remove from parent. Alright, now let's go to the myGame class, and like with the asteroids, we'll create a spawn component for spawning the pickups. So first, let's create a global variable for the spawner by typing late spawn component underscore pickup spawner. Now let's come down to the create asteroid spawner method, and we can start by duplicating the method and changing it to underscore create pickup spawner. And here we want to set underscore pickup spawner, and instead of creating an asteroid object in the factory function, let's create a pickup object, importing the pickup class. Like with the asteroids, we'll set the position by calling the generate spawn position method, and for the pickup type, we can choose a random value from the pickup type enum by doing pickup type.values brackets underscore random.nextInt pickup type.values.length. Now with the current min period and max period values, it's going to spawn the pickups way too often, but it'll be fine for testing purposes. Alright, and instead of adding asteroid spawner to the game, let's add underscore pickup spawner. Finally, we need to come up to the start game method and call underscore create pickup spawner. And with that, we get some random pickups that spawn at the top of the screen and move to the bottom. To make the pickups look a bit better, we can add a pulsating effect to them, making them constantly shrink and grow in size. For this, we can go back to the pickup class and add a scale effect to the components. So in the onload method, let's create the effect by typing final scale effect, import the effects package, then pulsating effect equals scale effect.2. We'll shrink it down to 90% of its original size by setting target scale to vector2.all 0.9. Then let's create a controller by typing effect controller. For the duration, let's go with 0.6. We want the component to also grow back to its original size, so let's set alternate to true. And we want it to repeat forever, so let's also set infinite to true. And to make the effect a bit smoother, let's set curve to curves, import the widgets package, then .ease in out. Finally, let's add the effect to the component by calling add pulsating effect. And now the pickups will have a nice pulsating effect as they move down the screen. Now we'll make it so the player can actually collect the pickups. For this, let's first go to the player class and down to the onCollision method. We're already checking if other is an asteroid, so let's add an else if here and check if other is pickup, importing the pickup class. If it is, we can go ahead and remove the pickup from the game by doing other.removeFromParent. And just for fun, let's increase the player's score by calling game.incrementScore 1. Next, we'll make it so when the player collects a laser pickup, it will allow them to shoot in 3 different directions for about 10 seconds or so. This means we'll need a timer, so at the top of the player class, let's do late timer, and let's call it _laser powerup timer. Then let's create the timer in the constructor by typing _laser powerup timer equals timer. For the duration, let's go with 10.0, and we don't want it to start yet, so let's set auto start to false. Also, by default, the repeat property is set to false, so the timer will only run once, which in this case is what we want. Okay, so now whenever the player fires a laser, we'll check if the laser power-up timer is running, and if it is, we'll create 2 extra lasers. We'll rotate one of the lasers 15 degrees counterclockwise and the other one 15 degrees clockwise and move them in the directions that they're facing. To do this, we'll first need to go into the laser class and make it so we can set the component's angle property whenever we create a new laser. So let's add a named parameter for this in the constructor by typing super.angle, and we'll give it a default value of 0.0. Next, in the update method, instead of simply changing position.y, we'll need to change the position using some trigonometry so that the laser moves in the direction of its angle. So let's do position plus equals vector2. For x, we want to get the sine of the angle, and we can do so using the sin method from the dartmath library and passing in angle. For y, we want the cosine of angle, but it needs to be negative in order to move the laser upward, so let's do negative cos angle. Then to this, let's do times 500 times dt, like before. If we run the game now, the lasers should still go straight up the screen. Okay, so now we need to go back to the player class and into the fire laser method. And here, after adding the straight up laser to the game, let's check if the laser power-up timer is running by typing if _laser power-up timer.isRunning. If it is, we'll create 2 more lasers, one with an angle of 15 degrees and one with an angle of negative 15 degrees. So first, we can copy and paste the line here for creating and adding a laser, and let's set the angle attribute to 15. A component's angle property, however, actually uses radians, so we need to convert the 15 degrees to radians. To do this easily, we can multiply it by the degrees to radians constant. Then we can copy and paste all of this and use negative 15. This won't work yet though, because we're never actually starting the laser power-up timer. So let's go back to the onCollision method. And here, if other is a pickup, we want to check its type. So let's do switch other.pickupType. For the laser pickup, let's do case pickup.laser : and call _laser pickup timer.start. If the timer isn't currently running, this will start it, and if it is currently running, this will restart the timer. Therefore, if the laser power-up is already active and the player collects another laser pickup, the timer will start over from the beginning, which is good. Now let's add a break statement here, and we also have to go ahead and handle the cases for the shield and bomb pickups, so for now we'll just use a break statement for each one. Okay, now we just need to go to the update method and update the timer if it's running. So after making sure the player isn't being destroyed, let's type if _laser powerup timer.isRunning _laser powerup timer.update dt. And that's it. If we now collect the laser pickup, we can shoot in 3 different directions at once. And if we don't collect another laser pickup, the laser will go back to normal after 10 seconds. Alright, next we'll work on the shield pickup. When the player collects a shield pickup, we'll make them invincible for 5 seconds and create a pulsating white ring around the player's sprite that destroys any asteroids it touches. Okay, so to start, let's create a new file for the shield component in the components folder, calling it shield.dart. For creating the shield, we'll load up a sprite using the shield.png image, which is a simple glowing white ring. Alright, so let's create the class by typing class shield, make it extend sprite component, and give it a reference to the game object. Now let's create a constructor, make a call to super, and we can go ahead and set the size to something like vector2.all to 100, and set anchor to anchor.center. And the constructor will have an empty body. Alright, now let's override the onload method, make it asynchronous, and load up the sprite by typing sprite equals await game.loadSprite shield.png. And because the shield needs to collide with the asteroids, let's give it a circle hitbox by typing add circle hitbox, importing the collisions package. Next, similar to the pickups, we'll give the shield a pulsating effect by adding a scale effect to it. So let's do final scale effect, import the effects package, then pulsating effect equals scale effect.2. We'll make the shield grow a bit by setting the target scale to vector2.all 1.1. Then let's create a controller by typing effect controller. For the duration, let's go with 0.6. We want the effect to alternate, so let's set alternate to true, and we want it to repeat forever, so let's set infinite to true. And to make it smoother, we can set curve to curves, import the widgets package, then .ease in out. Finally, let's add the effect to the component by doing add pulsating effect. Okay, now we need to go back to the player class and create a shield instance whenever the player collects a shield pickup. For this, we'll need a global variable for holding the player's currently active shield. The variable will need to be nullable for when there is no active shield, and public as we'll need to access it from the shield class. So let's do shield, import the class, add a question mark to make it nullable, and call it active shield. Okay, now when the player collects a shield pickup, we'll set active shield to a new shield instance and add the shield to the player components. However, if the player already has an active shield when they collect the shield pickup, we first want to remove the current shield and replace it with a new one. So for all of this, let's come down to the onCollision method, and if the pickup type is shield, we can first check if the player currently has an active shield by typing if active shield is not equal to null. And if so, we can remove the shield by typing remove active shield, adding an exclamation mark to tell it that the variable isn't null. Then below this, we can set active shield to a new shield instance by typing active shield equals shield. And finally, we can add the shield to the player by calling add active shield ! Adding it directly to the player component will make the shield move along with the player. Okay, let's give it a try. If we collect a shield pickup, we do get a pulsating shield that follows the player, but it's not currently positioned correctly. It doesn't destroy asteroids, it never goes away, and it doesn't make the player invincible. So let's fix all of these issues one by one. First, while still in the onCollision method of the player class, we can make the player invincible when they have an active shield by only calling the handle destruction method here if active shield is equal to null. And now the asteroids will have no effect on the player when a shield is active. Okay, now let's go to the shield class. Because we're adding the shield directly to the player component, the shield gets positioned in the game relative to the player. Therefore, with a default position of 0, 0 and a centered anchor, the shield gets centered at the player component's top left corner. So to center the shield in the player component, we need to move it to the right by half the player component's width and down by half the player component's height. We can do this in the onload method by simply typing position plus equals game.player.size divided by 2. And now the shield will be positioned correctly. Next, to make it so the shield can destroy asteroids, we need to check for collisions with the asteroid hitboxes. To do this, we first need to add the collision callbacks mixin to the shield class. Now we can override the onCollision method. And here we just have to do if other is asteroid, import the class, then other.takeDamage. And now any asteroids that a shield touches will get destroyed. Finally, we'll make it so the active shield goes away after 5 seconds. However, we don't want the shield to just disappear abruptly. Instead, we'll give the player a bit of a warning by fading the shield out for about 2 seconds before it goes away. To do this, we'll add an opacity effect to the shield. So in the onload method, let's type final opacity effect fadeout effect equals opacity effect.fadeout. Let's create an effect controller, and for the duration, let's go with 2.0. And we want to wait 3 seconds before fading out the shield, so let's set start delay to 3.0. Okay, now when the fade out effect has finished, we want to remove the shield from the player component. To do so, we can set the onComplete property to an anonymous function and call remove from parent. Doing this, however, will not immediately set the player's active shield variable to null, so the player component will think it still has an active shield. Therefore, we also need to make sure to set active shield to null by typing game.player.activeShield equals null. Now you might be thinking, what if the player has collected another shield pickup, so now this shield is no longer the active shield? That's actually not a problem though, because we're removing the old shield whenever the player gets a new one. Removing a component from its parent also removes all the component's children, which includes any effects that it might have. Therefore, if the shield gets removed before the fade-out effect has finished, its fade-out effect will get removed and the onComplete callback will never get called. Okay, and finally, let's add the effect to the shield by typing add fade-out effect. And now if we collect a shield pickup and don't pick up another one, the shield starts fading out after 3 seconds, then goes away. Excellent. Alright, we can close out of the shield file now, as well as the laser file, and the final pickup we need to work on is the bomb. As I mentioned earlier, this will be basically a flash of light that starts at the player's position and grows quickly, destroying any asteroids it touches before fading out. To create the bomb, we'll use the bomb.png image, which is a large circle with a white to transparent radial gradient. So to start, let's create a new file in the components folder called bomb.dart. Now let's create the bomb class by typing class bomb extends sprite component. with has game reference my game. And because we'll handle collisions between the bomb and the asteroids, let's go ahead and also add the collision callbacks mixin. Now let's create a constructor for the class. We'll pass in the position when creating the bomb, so let's add some curly braces in here and type required super.position. Now let's call the super constructor, and we'll start the bomb out really small by setting size to vector2.all1. We also want to set anchor to anchor.center, and the constructor will have an empty body. Okay, now let's override the onload method and make it asynchronous. And here we'll load up the sprite by typing sprite equals await game.loadSprite bomb.png. Then let's give it a hitbox by typing add circle hitbox. Alright, so what we want to happen when a bomb gets created is we want it to first grow pretty big, then fade out. This means we'll need to add two effects to the component, a size effect for growing it and an opacity effect for fading it out. And we want the opacity effect to happen after the size effect. To create a sequence of effects like this, we can use the sequence effect class. A sequence effect allows us to create a list of effects and have them run in order. Okay, so let's add a sequence effect to the component by typing add sequence effect and import the effects package. Now in here we can create a list, and the first effect we want to run is a size effect. Similar to scale effect, size effect has two constructors, sizeEffect.by for changing the size by a certain amount, and sizeEffect.to for changing the size to a certain amount. This is what we'll use for the bomb. So in the effects list, let's type sizeEffect.to. For the target size, let's do vector2.all800 to make the sprite grow to 800 pixels. Then for the controller, let's create an effect controller. Let's set duration to 1.0, and we can make it smoother by setting curve to curves, import the widgets package, then .ease in out. Okay, and once the size effect has finished, we want to fade the sprite out. So let's put a comma here, then do opacity effect.fadeout. Again, let's create an effect controller, and let's set duration to 0.5. Finally, we want to remove the bomb component from the game, and to do so, all we need to do is add a remove effect to the list, and it will run after the opacity effect has finished. Alright, now to deal with collisions between the bomb and the asteroids, let's override the onCollision method. And here we need to check if other is asteroid, import the class, and if it is, call other.takeDamage. With that taken care of, let's now go to the onCollision method of the player class. And here, if the collected pickup is a bomb, we'll add a new bomb to the game at the player's current position. So let's do game.addBomb, import the class, and set position to position.clone. If we run the game now and collect the bomb pickup, it sets off a bomb at the player's position. However, as we can see, it's actually possible for some asteroids to get through the bomb unscathed. Also, the bomb gets drawn on top of the player sprite, but it would probably be better if we drew it below the player sprite. To fix both of these issues, let's go back to the bomb class. First, to draw the bomb below the player sprite, we just need to go to the constructor, and in the call to super, we can set priority to something less than 0, like -1. Okay, and the reason the bomb doesn't always destroy all the asteroids is that by default, Flame only detects collisions using the edges of the component's hitboxes, as this requires fewer calculations. This works well most of the time, but because the bomb grows so quickly, when an asteroid splits into smaller segments, the segments will often get created inside the perimeter of the bomb, so no collisions will be detected. To fix this, when creating the circle hitbox here, we can set its isSolid property to true. This will force Flame to also detect collisions within the hitbox's perimeter, and now it will also destroy any asteroids that get created inside the bomb. And we can actually improve the collision detection performance a bit. By default, Flame detects collisions between any two components that have hitboxes. This is good for when an asteroid touches a bomb, a laser, a shield, or the player, but at the moment it also detects collisions between the asteroids themselves, which is unnecessary. To override this behavior, we can go to the Asteroid class, and when creating the circle hitbox here, we can change its collision type property. To see the available options, we type collision type dot. So we have active, inactive, and passive. An active hitbox can collide with other active hitboxes as well as with passive hitboxes. Inactive hitboxes can't collide with anything, which is useful for times when we would like to disable a component's collisions. And finally, passive hitboxes can only collide with active hitboxes. So if we change the hitbox type to passive for all the asteroids and leave the hitboxes for the other components as active, Flame will still detect collisions between the asteroids and the other components, but not between the asteroids themselves. We won't really notice much of a difference with this, but if we were to create hundreds of asteroids at a time, this would definitely improve the performance of the game. Okay, we're finished with the pickups now, so let's go to the MyGame class and find the create pickup spawner method. We don't want to spawn the pickup so often in the finished game, so let's set min period to 5.0 and max period to 10.0 to spawn one every 5 to 10 seconds. And with that, we basically have a complete game. So now we'll work on some things that are nice to haves, like a title screen, a game over screen, some audio, and some moving stars in the background. And we'll start with the stars. For this, we'll create some small white circles that move down the screen. And we'll give them a parallax effect by making some stars smaller, slower, and more transparent than other stars so that they appear to be farther away from the player. Alright, so to begin, let's create a new file in the components folder and call it star.dart. As I mentioned before, we'll create circles for the stars. So for the class, let's do class star extend circle component and give it a reference to the game object. We'll be using a lot of randomization in this class, so let's create a global random instance by typing final random import dart math, then underscore random equals random. We'll also create a couple global variables for the maximum size a star can be and for the speed of a star. So for this, let's do final int underscore max size equals 3, then late double underscore speed. Okay, now let's override the onload method and set up some things. First, for the size of the star, we'll choose a random integer between 1 and the max size. So let's do size equals vector2.all 1.0 plus underscore random.nextInt underscore max size. Next, for the starting position, we'll randomly choose a point anywhere on the screen. So let's type position equals vector2, and for x, let's do underscore random.nextDouble times game.size.x, and for y, underscore random.nextDouble times game.size.y. Alright, now for the speed, we'll randomize the value a bit as well, but we'll also make it so the bigger a star is, the slower it will move. So for this, let's set underscore speed to size.x times parentheses 40 plus underscore random.nextInt 10. Finally, we need to set the color of the star. We'll use white for this, but we'll make it so the smaller a star is, the more transparent it will be. To set the color, we can do paint.color equals color, import the widgets package, then .from RGBO 255, 255, 255, and for the opacity, let's do size.x divided by underscore max size. Next, we want to use the star's speed to move it down the screen during every frame of the game. And once it reaches the bottom, we'll move it to the top of the screen and give it a new random X position. Okay, so let's override the update method, and to move the star down using its speed, we can do position.y plus equals underscore speed times dt. Then if the star has reached the bottom, we'll move it to the top and give it a new X position. For this, let's type if position.y is greater than game.size.y plus size.y divided by 2. Then position.y equals negative size.y divided by 2, and position.x equals underscore random.next double times game.size.x. And that's all we need to do in the star class, so we can close out of the file and head over to the MyGame class. First, let's come down here and create a new method by typing void underscore create stars. And here we'll simply use a for loop to create about 50 stars or so. So let's type for int I equals 0, I less than 50, I plus plus, add star, and import the class. However, we also want to make sure the stars appear behind all the other components in the game, so let's set the stars priority by typing priority equals -10. Finally, for calling the createStars method, we'll actually do so from the onload method, not the startGame method. This is because we're going to allow the stars to continue running throughout the entirety of the game, and we're eventually only going to call startGame when the player clicks the start button on the title screen. Alright, so before calling startGame here, let's call underscore createStars. And now we get some nice looking stars scrolling down the background. Very cool. Okay, next we'll make it so when the player dies, we'll fade in a game over screen with buttons for either restarting the game or quitting the game and going back to the title screen. The best way to add things like menus and screens with UI elements to a Flame game is to work with overlays. Overlays allow us to overlay Flutter widgets directly on top of the game. Okay, so let's start by creating a new folder for the overlays inside the lib folder and call it overlays. Then let's create a file inside the overlays folder and call it game_over_overlay.dart. Because we'll be using normal Flutter widgets for this class instead of Flame components, we'll extend either stateless widget or stateful widget. And because we'll be fading the overlay in and out, we'll extend stateful widgets. So to easily create the class using a stateful widget, we can type the shortcut stful, press enter, and call it GameOverOverlay. Now we're also going to need access to the game object. However, overlays don't get added to the game object the way components do, so we can't use the hasGameReference mixin. Instead, we'll need to pass in a reference to the game when creating the overlay. So let's first create a global variable for the reference by typing final mygame, import the class, then game. Then let's add it as a named parameter for the constructor by typing required this.game. Okay, so the GameOverOverlay is going to have a black semi-transparent background that covers the entire screen, as well as some text that says Game Over, a Play Again button, and a Quit Game button that are all centered on the screen. So in the build method, let's return a container widget. Let's set the container's color property to colors.black and make it semi-transparent by adding .widthAlpha 150. And let's set alignment to alignment.center. We'll lay out the text and buttons in a column. So for the container's child, let's use a column widget. To center the column's children horizontally on the screen, we have to set its main axis alignment property to main axis alignment.center. Then let's create a list of children. The first one will be the game over text, so let's do const text and set the text to game over. For the style property, let's do text style, set color to colors.white, font size to 48, and font weight to fontweight.bold. Next, to add some spacing between the text and the play again button, let's go below the text widget and do const sized box and set height to 30. Alright, for the play again button, let's add a text button widget. For on pressed, let's just create an empty function for now. For style, let's do textButton.styleFrom. We'll add some padding around the button's text by setting padding to const edgeinsets.symmetric vertical 10, horizontal 25. For background color, let's go with colors.blue. And let's give the button rounded corners by setting shape to rounded rectangle border and setting its border radius to border radius.circular 50. Okay, below the style, let's create the button's text by setting the child property to text, set the text to play again, and set style to text style with a color of colors.white and a font size of 28. Next, below the play again button, let's add another sized box for spacing by typing const sized box height 15. Finally, we can add the quit button by first copying and pasting all the code for creating the play again button, then changing the text to quit game. Alright, now to start using an overlay, we have to go to the main.dart file, and for the game widget here, we have to provide its overlay builder map property with a map containing information for the overlays. For the key, we can use any string to identify the overlay, for example, game over, and for the value, we provide a function for building the overlay. For this, we can create an anonymous function, use context and myGameGame as the parameters, then return an instance of GameOver overlay, making sure to import the class and set the game argument to the game reference. Okay, now to bring up the overlay when the player dies, let's go to the myGame class. We'll create a public method in here that we'll call when the player dies. So let's create the method by typing void player died. And for now, we'll simply bring up the GameOver overlay. To do this, we can access the game's overlays property, which is an overlay manager object, then call its add method and pass in the string for the name that we're using for the GameOver overlay and overlay builder map. So game over. Finally, for calling the player died method, let's go to the player class and find the handle destruction method. And here we can set the remove effects on complete property to game.playerDied, and it will call the method as soon as it removes the player component from the game. Alright, so now if we play the game and die, after the player finishes exploding, the game over overlay pops up. At the moment, of course, the buttons don't actually do anything, and we'll fix that in a bit. But first, if we would like to stop the stars, asteroids, and pickups from continuing to move down the screen, we can pause the game engine. To do this, let's go back to the playerDied method in the myGame class, and all we have to do in here is call the pause engine method. Now everything will freeze once the game over overlay comes up. Alright, and the overlay also comes up a bit too abruptly, so we'll make it fade in. To do so, let's go to the GameOver overlay class. In the state class, we'll first create a global variable to keep track of the overlay's current opacity. So let's type double_opacity, and we'll start it out fully transparent by setting it to 0.0. Next, we need to wrap the container widget here with a new widget and use an animated opacity widget. With this, we can set the opacity property to _opacity, and we can tell it how long the animation should take by setting the duration parameter. For this, let's go with const duration and make it last half a second by setting milliseconds to 500. In order for this to work though, we have to also override the initState method. And here, let's do future.delayed and set the duration to const duration milliseconds 0 so that the animation starts straight away. Then let's add an anonymous function in which we can do set state underscore opacity equals 1.0. With this, as soon as the overlay gets created, its opacity will animate from 0 to 1 over half a second. Okay, let's give it a try. Much better. Alright, now we'll get the Play Again button working. For this, let's start by going to the MyGame class, and let's create a new public method by typing void restart game. And here we'll need to reset a few things. First, we'll remove any asteroids and pickups that are currently in the game. To do this, we can access the game's children by using the children property, get all the position components by doing .whereType angle brackets position components, then loop through the components by typing .forEach, providing an anonymous function with a parameter for the current components. Inside the function, we can check if the current component is an asteroid or a pickup by doing if component is asteroid or component is pickup. And if so, we can remove it from the game by calling remove and passing in components. Similarly, we want to reset the asteroid and pickup spawners, which we can do by calling _asteroid spawner.timer.start and _pickup spawner.timer.start. We also want to reset the score to 0, so let's type _score equals 0 and _score display.text equals !0. And because we're removing the old player sprite from the game once it finishes exploding, we'll need to create a new player sprite, so let's call _createPlayer. Finally, to resume the game engine, we can call resume engine. Okay, now for calling the restart game method, let's go to the game over overlay and find the play again button. Inside its onPressed function, we can call widget.game.restartGame. However, we also need to get rid of the overlay. We'll do this by first fading the overlay out, then removing it. So first, let's do set state _opacity equals 0.0. Then for actually removing the overlay, let's come up to the animated opacity widget and set its onEnd property. For this, let's create an anonymous function. This function will be called both when the overlay fades in and when it fades out. We of course only want to remove the overlay after it fades out, so let's first check if it is fully transparent by typing if _opacity equals 0.0. And if so, we can remove the overlay by calling widget.game.overlays.remove game over. And that's it. If we run the game and die now, clicking the play again button fades out the overlay and the game restarts. Awesome. Okay, now before we can get the quit game button working, we first need to create the title overlay. So to start, let's create a new file in the overlays folder and call it title_overlay.dart. For the title overlay, we'll display the game's title, Cosmic Havoc, at the top. Below that, we'll have an image of the player's spaceship flanked by 2 arrow buttons. The player will be able to click the arrow buttons to change the color of their spaceship. Next, we'll have a start button for starting the game. And finally, we'll have buttons at the bottom right for toggling the music and sound effects on and off. And like with the game over overlay, we'll fade the title overlay in and out. So for the class, let's type stful, press enter, and call it title overlay. We'll need a reference to the game, so let's create a global variable for it by typing final myGame and make it a required parameter in the constructor. Next, in the state class, let's create an opacity variable by typing double _opacity equals 0.0. Then for fading the overlay in, let's override the initState method. And here let's do future.delayed set the duration to const duration milliseconds 0, then provide an anonymous function where we can do set state underscore opacity equals 1.0. All right, now in the build method, let's return an animated opacity widget. Let's set opacity to underscore opacity and duration to const duration milliseconds 500. Next, to keep things vertically centered on the screen, let's set the animated opacity's child to container and set the container's alignment to alignment.center. Then for the container's child, let's go with column. We'll add a bit of spacing between the title image and the top of the screen. So for the column's children list, let's first do const sized box and set height to 60. For the title image, we'll use title.png from the images folder, and we'll put it inside a sized box. So let's add another sized box to the list and set width to 270. For the box's child, let's do image.asset. And here we have to provide the entire path for the image. So let's type assets/images/title.png. Next, we'll create the arrow buttons and the player image display, and we'll place these inside a row. But first, let's add some spacing below the title image by doing const sized box height 20. Then let's add a row to the list. To make the row use only the minimum amount of width necessary, let's set its main axis size property to main axis size.min. Then let's work on its list of children. The first one will be the left arrow button. If we take a look at the images, we only have a single image for the arrows, arrow_button.png. The arrow in the image faces to the right, so for the left button, we'll need to flip the image horizontally. Also, we of course want the image to be clickable, so for the first child of the row, let's go with Gesture Detector. We'll create an empty onTap function for now, and for the Gesture Detector's child, let's go with transform.flip. To flip it horizontally, we set flipX to true. Then for the child, let's go with sized box, give it a width of 30, and a child of image.asset, assets/images/arrow_button.png. Next, we'll have the player image display, and for now, we'll just use the player blue off image. We also want to add some padding between the display and the arrow buttons. So below the gesture detector, let's do padding and set the padding property to const edge insets.symmetric horizontal 30. Okay, for the padding widget's child, let's do sized box with a width of 100. And for the child of this, let's do image.asset, assets/images/player_blue_off.png. Finally, after the padding widget, we'll create the right arrow button. So we can start by copying and pasting the code for the gesture detector here. The only difference with this one is we don't need to wrap the image's sized box here with a transform widget. So we can right-click the transform widget, refactor, and remove it. All right, below the row, we'll create the start button. So first, let's add some spacing by doing const sized box height 10. For the start button, we'll use the startButton.png image, and to make it clickable, let's start by adding a gesture detector. OnTap will be an empty function for now. And for the child, let's do sized box, set width to 200, and set child to image.asset, assets/images/start_button.png. Okay, I think that's good enough for now. We'll wait to create the audio toggle buttons after we have added the audio. So to get the title overlay working, let's first go to the main.dart file, and we'll need to add it to the overlay builder map. For the key/name, we can use the string title, And for the builder function, we can do the same as we're doing for the game over overlay using context and myGameGame as the parameters, but this time returning title overlay, making sure to import the class. Alright, and to make it so the title overlay pops up as soon as we run the game, we can set the game widget's initial active overlays property. This takes a list of names for overlays that we want to run as soon as the game runs. So to make the title overlay run, we can do const brackets, quote title. However, if we go to the myGame class, its onload method will also run immediately. And because we're calling start game here, the gameplay will start with the title overlay displayed on top of it. The only thing we want to have below the title overlay is the stars in the background. So let's remove the call to start game here, as we'll instead call it when the player clicks the start button. Okay, if we run the game now, the title overlay fades in, with the stars scrolling down the background. Very cool. Now to get the start button working, let's go back to the title overlay file. When the player clicks the start button, we'll call the start game method and also fade out the overlay and remove it. So in the onTap function of the start button's gesture detector, let's first call widget.game.startGame. Then let's do set opacity _opacity equals 0.0. Now let's come up here and set the animated opacities widget onIn property to a new function where we can check if _opacity is equal to 0.0, and if so, call widget.game.overlays.remove title. And now if we run the game and click the start button, the overlay fades out and the game starts. Next, when we die and bring up the game over overlay, we want the quit game button to clear the screen of everything but the stars and bring up the title overlay. To do this, let's first go to the myGame class and let's create a new public method down here by typing void quitGame. And here we want to remove everything from the game except the stars. To do so, we can loop through all the game's position component children like we're doing in the restart game method by typing children.withType positionComponents.forEach, creating a new function in here with the component parameter, and in here we can check if component is not star, then remove component. This, however, will not remove the asteroid and pickup spawners from the game, as spawn components don't extend the position component class. So let's also remove them by typing remove _asteroid spawner and remove _pickup spawner. After that, we can show the title overlay by calling overlays.addTitle. And finally, to get the stars scrolling again, we need to unpause the game engine by calling resume engine. Okay, now let's go to the game over overlay file and find the onPressed property of the quit game button's text button widget. Inside the function, let's call widget.game.quitGame. And to fade out the overlay, let's do set state _opacity equals 0.0. And with that, if we now click the quit game button, it brings up the title overlay with only the stars in the background. Perfect. Alright, next we'll make it so the player can change the color of their spaceship. In order to do this, let's first go to the myGame class, and we'll need to create a couple public global variables. One for a list of strings to represent the possible player sprite colors, and one for the current index to use in the list. Okay, so for the list, let's do final list string player colors equals brackets. And the possible colors are blue, red, green, and purple. Then for the index, let's do int player color index, and we'll initialize it to 0 for blue. Now for actually using the chosen color, let's go to the player class. At the top, let's create a variable for the player sprite's color by typing late string _color. Then in the onload method, before setting the animation property, let's set _color to game.playerColors, game.playerColorIndex. Now in the load animation method, we can use the color variable when loading up the sprites by changing the word blue in both of these strings to $_color. Then let's also go to the handle destruction method and do the same here. Okay, just to make sure we didn't break anything, let's run the game and click Start, and we're still using the blue images. Great. Now let's head over to the title overlay file and get the arrow buttons working. First, we want to make sure the spaceship display uses the image that corresponds to the currently chosen color, and we'll start by creating a new variable at the top of the build method to hold the current color. So let's type final string player color equals widget.game.playerColors, widget.game.playerColorIndex. Then let's come down to the sized box for the player image, and let's change blue in the asset string here to $player color. Okay, now for cycling through the colors, we'll start with the right arrow button. So let's go into its onTap function. And here we want to increase the player color index variable. However, we also want the display image to update. So first, let's do set state. Then we can do widget.game.playerColorIndex++. If it goes past the end of the player colors list though, we need to reset it to 0. So let's type if widget.game.playerColorIndex is equal to widget.game.playerColors.length, then widget.game.playerColorIndex equals 0. Next, for the left arrow button, we want to cycle through the colors in the opposite direction. So first, we can copy and paste the lines from here into the left button's onTap function. This time we want to do player color index --. In the if statement, let's check if player color index is less than 0, and if so, let's set it to widget.game.playercolors.length -1. And with all of that, we can now use the arrow buttons to cycle through the images. And if we start the game, it will use the chosen color. One thing that's kind of annoying though, is that the first time we cycle through the images, there are brief moments when no image is displayed, causing a flicker. Also, I think the display would look better if we move the images down a bit. To fix the first issue, inside image.asset for the player image, we can set the gapless playback property to true. And to move the images down a bit, instead of doing edgeInset.symmetric for the padding widget's padding property, we can do edgeInsets.only and set left to 30, right to 30, and top to 30. And now the display should look better and have no flickering. Awesome. Alright, all we need to do now is add some music and sound effects to the game. For playing audio, Flame provides the Flame Audio package. And while this does work for both music and sound effects, I actually ran into some memory leak problems when using it for sound effects on Android. Because of this, we'll only use Flame Audio for music, and for the sound effects we'll use Soundpool, both of which we already added to pubspec.yaml. Okay, and to make our lives easier, we'll create an audio manager for handling all the audio. This will actually be a component that we add to the game, so let's create a new file in the components folder and call it audio_manager.dart. For the class, let's do class audio manager, and it won't need any special properties, so we can simply extend the component class. It also won't need a reference to the game objects. Okay, so because we're going to allow the player to toggle the music and sound effects on and off, we'll need a couple public global variables for keeping track of whether or not they are currently enabled. So for this, let's do bool music enabled, and we'll initialize it to true. Then let's do bool sounds enabled and set it to true as well. We'll create some more variables for the sound effects in a bit, but for now we'll go ahead and get the music working as it's pretty easy to do. First, we need to override the onload method. And here, if we do flame audio, import the package, then dot, there's a BGM object that we can use for playing background music. In order to use it, we first need to initialize it by calling its initialize method. Alright, now for actually playing the music, let's come down here and create a new public method by typing void play music. We only want to play the music if the music is enabled, so let's first check if music enabled, and if so, we can call flameaudio.bgm.play. This takes a string for the name of the music file, and it automatically looks inside the assets/audio folder. The music file is called music.ogg, so in here we can simply pass in quote music.ogg. The play method will also loop the music, which is good. Okay, now let's go to the MyGame class. First, we'll need to create a public global variable to hold the audio manager instance. So for this, let's type late final audio manager, import it, then audio manager. Next, we want the music to start as soon as the title overlay comes up, so in the onload method, we'll initialize the audio manager and play the music. To initialize it, let's do audio manager equals audio manager. We also need to add it to the game, and we need to wait until this is done before we play the music. To do so, we can type await add audio manager. Finally, we can call audiomanager.playMusic. Okay, if we run the game now, we get some music playing in the background. Now let's go back to the Audio Manager class and we'll use Soundpool to play the sound effects. So basically what Soundpool does is it creates a pool of audio players and cycles through them as we play various audio files. This allows us to play multiple sounds at once and in quick succession. Alright, so first, to help with loading up the sound effect files, we'll create a global list of strings for their titles. All of the audio files, apart from music.ogg, are sound effects, and they all end with .ogg. So for the list of strings, we'll add all the sound effect titles without the .ogg parts. Okay, so let's do final list string underscore sounds equals brackets click, comma collect, comma explode 1, comma explode 2, comma fire, comma hit, comma laser, and comma start. Next, Soundpool creates an integer ID for each sound file that we load, and we'll store these IDs in a map using the sound titles as the keys. So for this, let's type map string comma int underscore sound IDs equals curly braces. Finally, for creating the Soundpool instance itself, let's do final Soundpool, import it, then underscore Soundpool equals Soundpool, and we'll use the from options constructor. By default, Soundpool only creates a single audio player. This will only allow us to play one sound effect at a time, which obviously isn't going to work. So to tell it to create more audio players, we can set the options property to const Soundpool options, and in here we set max streams to the number of players to create. I think 10 should be enough. Okay, that's it for the variables. So next, in the onload method, we'll load the sound effect files, and we'll store the IDs in the sound IDs map. To do this, let's loop through the sounds list by typing for string sound and underscore sounds. And here, let's set the corresponding sound IDs map entry using underscore sound IDs sound. And we'll set it to await root bundle.load quote assets/audio/$sound.ogg. Then let's do .then and create a function in here with byte data as a parameter. Finally, inside the function, we can do return_soundpool.load data. Long story short, this will load the sound file into memory, creating an ID for it, which we're storing inside the sound IDs map. And to get rid of this error, we need to make the onload method asynchronous. Okay, now for playing a specific sound effect, let's create a public method by typing void playSound with a parameter of string sound. We only want to play a sound if the sounds are enabled, so let's first check if sounds enabled. If so, to play a sound, we use _soundpool.play. This takes an ID for a loaded sound file, so to play the given sound, we can use _soundids sound. And we have to add an exclamation mark here to tell it that it won't be null. And that's it. Now we can call this method anytime we want to play a sound effect. Let's start with the title overlay. We'll play the click sound when the player clicks either of the arrow buttons, and we'll play the start sound when they click the start button. So first, inside the onTap function for the left arrow button, let's call widget.game.audiomanager.playSound and pass in the string click. Then we can copy and paste this line into the onTap function for the right arrow button. Then let's also paste it in the onTap function of the start button, but change the string to start. And while we're at it, let's also go to the Game Over overlay file and play the click sound whenever the player clicks one of the buttons. And now, clicking the arrow buttons on the title overlay will play the click sound. Clicking the start button plays the start sound, and if we bring up the Game Over overlay, clicking one of the buttons plays the click sound. Awesome. Next we'll play the laser sound whenever the player fires a laser. For this, let's go to the player class and find the fire laser method. All we need to do in here is call game.audiomanager.playSoundLaser. And while we're inside the player class, we'll also play the collect sound when the player collects a pickup. So let's go to the onCollision method. And in the else if other is pickup check here, we can do game.audiomanager.playSoundCollect. All right, let's give it a try. It plays the laser sound when shooting lasers and the collect sound when collecting pickups. Very cool. Next, we'll play the hit sound whenever the player shoots an asteroid, and whenever an explosion occurs, we'll randomly play either Explode 1 or Explode 2. So first, let's go to the Asteroid class and into the Take Damage method. And here let's call game.audiomanager.playSoundHit. Then let's go to the Explosion class. In the onload method, let's first generate a random number between 1 and 2 by doing final int num equals 1 plus _random.nextInt2. Then we can play a random explode sound by typing game.audiomanager.playSound "explode $num." Now let's give it a try. We get hit sounds when shooting asteroids and explode sounds when an asteroid explodes. This works for the player explosions as well. Finally, we'll play the fire sound when setting off a bomb. So let's go to the bomb class, and in the onload method, let's type game.audiomanager.playSoundFire. Then give it a try. Excellent. Alright, now that the audio is working, all we need to do now is make it so the player can toggle the audio on and off. For this, we'll first need to go into the Audio Manager class and create a couple more public methods. For the first one, let's do void toggle music. And here, let's change the value of music enabled by typing music enabled equals not music enabled. Also, if the music has been enabled, we'll play the music. Otherwise, we'll stop it. So let's do if music enabled, play music, else flameaudio.bgm.stop. Similarly for the sound effects, let's create a method with void toggle sounds. And all we need to do in here is type sounds enabled equals not sounds enabled. Okay, now let's go to the title overlay file and create the audio toggle buttons. We'll place these at the bottom right of the screen, so let's come down here below the Start Buttons gesture detector. In order to position the buttons at the bottom right corner, the parent widget needs to fill in all the remaining screen space. For this, we can use an expanded widget. For the child, let's use an align widget and set its alignment to alignment.bottomright. We'll put some padding between the audio buttons and the sides of the screen. So for the align widget's child, let's use a padding widget and set padding to const edgeinsets.all10. Then for the padding widget's child, let's use a row. We want the row to only take up as much space as necessary, so let's set its main axis size property to main_axis_size.min. And for the row's children list, we'll create the audio buttons. For these, we'll use icon button widgets. So let's add an icon button. Let's give it an empty onPressed function for now, then set its icon property to icon. This one will be for the music toggle, and we'll choose a different icon depending on whether or not the music is currently enabled. So for the icon, we'll use a ternary statement by first typing widget.game.audiomanager.music_enabled ? For the enabled icon, we'll go with icons.music_note_rounded. And for the disabled icon, let's do icons.music_off_rounded. Okay, and we'll also make it so the icon is white when the music is enabled and gray when it's disabled. For this, we can set the color property to widget.game.audiomanager.music_enabled ? colors.white : colors.gray. Finally, let's set the size property to 30. Alright, for the sound effects toggle, we can start by copying and pasting the entire icon button widget. This time, we want to check sounds enabled for both ternary statements. For the enabled icon, let's go with icons.volume_up_rounded. And for the disabled icon, we'll do icons.volume_off_rounded. Okay, let's run the game and make sure the buttons show up correctly. Cool. Now we just need to get them working. First, inside the music button's onPressed function, we want to call the audio manager's toggle music method, but we also want to make sure the button switches to the correct icon. So first, let's do set state. Then we can call widget.game.audiomanager.togglemusic. Similarly, for the onPressed function of the sounds toggle, let's do set state widget.game.audiomanager.togglesounds. Okay, let's give it a try. We can toggle the music on and off, and we can toggle the sound effects on and off. Fantastic. And with that, we are officially done with Cosmic Havoc. If you followed along, awesome work, and I encourage you to continue working on yours and add some more things, like maybe a persistent high score, or perhaps give the player some health, along with a health bar that follows their sprites. Alright, thanks for making it until the end, and I'll see you in the next one.